So welcome everyone to the 2026 Marine Conservation and Policy Symposium. My name is Kaitlin Giglio. Most of you know me. I'm the interim director of the MCP program. I'm thrilled for us to be here today, where we get to celebrate the outstanding accomplishments of our graduating MCP students. Over their time in this program, they have worked their butts off in the classroom, and then they have thrown themselves directly into the deep end of ocean conservation. Through rigorous capstone projects and immersive professional internships, they've tackled complex, urgent environmental issues without hesitation and with truly admirable commitment. Our students have not focused on just one corner of our blue planet or on one mechanism for making it better. This symposium is the perfect showcase of that diversity. Today, you're going to hear students talking about their lab-based experiments or their field-based monitoring efforts. Some will share about policy analyses, education and outreach initiatives, and examinations of how news media coverage impacts public perception of marine-related issues. Some of our students relied on local issues and stayed right here. Others traveled oceans to deal with marine conservation issues elsewhere. Together, these capstone projects and internships represent a crucial bridge for our students from going from being a student to being a professional. Now, side note to my graduating students, that doesn't mean you're done learning. One of the things I hope that you've learned during your time at SoMAS is that the scientific community is always deepening our understanding of marine conservation and marine policy. And so you have to do the same thing. Moving forward, you're not going to be doing it in a classroom, and you're not going to be doing it to get an A on your paper, but you'll be managing your own ongoing learning, so that way you can turn scientific discovery into real-world conservation efforts and actionable policy. I have every confidence that you will be doing this and making a splash after you graduate from here. Your hard work and passion are on full display today, and we can't wait to see what you achieve next. To our guests, faculty, and partners, thank you for mentoring and supporting these students this year. And thank you for collaborating with our newest generation of ocean advocates leaders. To our incoming students who are also here today, use today as a springboard to build your own momentum. Before you know it, you're going to be standing where I'm standing right now with this little microphone clipped on, and you're going to be scared out of your pants, but you'll be fine. And you're going to be sharing your capstone and your internship experiences. To officially kick off our morning, I want to welcome Dean Shepson to give a few opening remarks. After, I'm just going to go over some logistics, and then I'm going to hand the microphone over to our students. I'm going to give you this so that way our recording works.
Okay.
Sometimes the microphone's the scariest part.
I still get nervous. I'm 69, which, to some of you might sound really young, but I still get nervous when I'm speaking in public, and just a way of saying to yourself that you care about it. So I stand between you and the coolest event of the year. So I'm going to be brief, but welcome to the 2026 MCP Symposium. This is indeed an incredibly exciting event as we hear about and ask good questions about your projects and what you achieved and what you got out of them. I want to thank you all for entrusting us with a year of your lives for this program. We think it's a fantastic investment for you. We might not be objective, but we think that. We work hard to make this, master's degree in 1 year doable and meaningful and high quality for you that will help support, act as a springboard for your most excellent careers that are just budding. But we're also proud of you for the focus you have applied to this over the last year and getting it done. So congratulations to you. This is my favorite SoMAS event of the year. Don't tell the other people who organize the other events, but as a marine science student myself, I always learned a great deal from your presentations. I'm progressing, becoming a little more knowledgeable. By the time I retire, I might be incredibly more than just a student of marine sciences. So this is not the end of your relationship with SoMAS, hopefully not the end, but just the beginning. Many of you will find employment in the region. We'll hear from you. We want to hear from you. In many cases, we work with you later on. We hope that that's the case because we'll continue learning from you. So I just want to say thanks for being an MCP student, and I'm gonna sit back and listen and get enriched. So congratulations to you and thank you.
Your microphone before you leave with it. All right, just a quick note on logistics. So we have 18 students presenting today. That is a lot of you. You all have 10 to 12 minutes to really do your presentation. At 10 minutes, I'm sitting right up there. I'm going to raise my hand. It's 10 minutes is not like you need to stop right now. It's just, hey, it's 10 minutes. At 12 minutes, I'm going to stand up right over there. And at 14 minutes, I'm going to start walking towards you. And eventually, I'm going to be standing right next to you. So this gives us a minute or so at least for questions before we get to the next person. And like I said, 18 means if we don't stay on track, we won't be on track. We're going to start with Adrian Espinoza. He worked with Mary Collins and Joe McClenachan looking at social and ecological effects of climate resilience, nature-based social infrastructure in Brooklyn. Here you go. You're going to put this on and I'm going to get your presentation up. Let's make sure we're sharing our screen. Oh, you're at the end.
Yep.
You are not off. You're done. That went well, right?
Yeah.
Oh, there we go.
Okay, good morning, everyone. Hi, my name is Adrian Espinoza, and again, my project is quantifying the social and ecological effects of climate resilience of nature-based social infrastructure within Brooklyn, New York City. So what is NBSI and why Brooklyn? So NBSI is nature-based social infrastructure. So this includes some things like parks, community gardens, resort wetlands, greenways, and beaches. These places are essential, not because it's only infrastructure, but they provide ecological services like flood mitigation, protection from storm surges, and heat reduction. They also provide a means for community gathering in order to build trust, cohesion, and adaptive capacity within communities. Additionally, Brooklyn was chosen because there are a lot of marginalized communities that are at greater risk of these events happening, and yet they receive the most fewer installments of climate resilient infrastructure. So if you can see flooding, there's been happening flooding all over Brooklyn, as well as massive heat waves. So why climate resiliency matters? So parts of Brooklyn, specifically southern Brooklyn, are in danger of extreme weather events, mainly because they're in low-lying topography. If you can see in the image, this is the main Coney Island area with a few of the parks that we actually studied. I believe Kaiser Park, Calvert Park, Marine Park, all those types of parks are in this area, and they're the ones being most affected in these neighborhoods. So this map specifically was after Hurricane Sandy, but it just shows how bad it got, even in current events now. So in most places of Brooklyn, there's at least above 10 feet of flooding happening. And marine conservation comes into play as it is important to notice that flooding is not only an issue of urban planning, it is also a coastal ecosystem issue as well. If our coasts are not able to take up this resilience from extreme weather events, then the infrastructure we have in place is either in trouble or doomed to deterioration. So our project objectives. So our objectives was essentially to go to 20 different parks all around Brooklyn with many different places and communities. We had to get again these different places from each individual community, and they all had their own different each infrastructure. So we also placed multiple temperature and water loggers before collecting flooding and temperature data. We additionally asked community surveys to see how they feel about the parks and how they handle these extreme weather events. Collecting observational data to determine who uses the park and how and why. And that was really important. And it's just essentially connecting to seeing what people want to tell us, hearing what they have to say. Additionally, from all types of ages, races, and opinions, obviously. We got all types of data. So what was done in the field? So the first image here is a temperature logger. We replaced temperature loggers throughout the parks. For the most part, we would pick 4 temperature loggers throughout the park. Typically, it would be 3 pervious logger like sites, which means they're like covered in shade. They get the most. I guess like if you were a person, you get the most access and like ability to be protected against anything. And then the last logger will obviously be impervious, which would be like either in a court, a tennis court, a basketball court, which is where the most heat happens, and that's where the most effect will be shown. Additionally, we also placed water loggers. So we would put at least 1 water logger. We found like around between 10 to 12 parks. We had to choose very selectively about which water logger we would place because they are expensive and not every place actually did get flooding. And lastly, logger percent covers. So when we would go in the field, we would essentially just write down where the logger was, what is it under, is it, under asphalt, is it in the ground, all that type of stuff. So that we can quantify, what is actually being affected for these loggers to get the data that they need, essentially. So we put their location, their description, and that's pretty much about it. And then we put it into an Excel file. So my field experience, essentially tabling. Again, like I mentioned before, we did community surveys. So on days we did community surveys, it would at least be 2 people. 1 person would be doing the surveys, but the other person would be doing observational data. For the surveys, we would tell people, hey, this is a quick 5-minute survey, completely anonymous. And if they wanted to stop at any point, they were more than welcome to. Additionally, our participants were above the age of 18 or older. The goal was to essentially get 30 surveys per park. I'm going to explain that in a little bit, how we would get 30 surveys to quantify it. And the survey basically asked individuals various questions about this current heat and flooding affect them and what they could essentially do in that situation. Observational data, the other person that was there tabling with us would essentially just be sitting down, taking track of who came into the park, what they were doing, how old they were, just to quantify who's actually using the park, why are they using it, do they come in groups or not. Essentially, if they were in a group of 2 or 3, we would write that down, but if they were in a group of 3 or 10 more, we would also put that down just to quantify our better results. And each survey station was taken in 2 different sections, mainly one during the weekday and then obviously a weekend time frame. So for the morning section, it would be from 12 to 2, and then from 4 to 6, we would take a 2-hour grab just so we can get a good circulation of people. And for the weekend, it was same thing from 10 to 1, and then from 2 to 5, sorry. Again, just to get a new circulation of people, see if we got any people new, if they came back. Sometimes we would get people who would come back, but they were doing different activities in the park, so we would put that down. And again, we were given at least 2 hours on weekdays to get a new circulation of people. Challenges and setbacks, we had a few various challenges here. So uneven park visitations, I will explain that in a little bit once we get to the weather-related events. But we would definitely have like some uneven park visitations, whether it was like an external factor, an internal factor, maybe we didn't have enough people one day. So we had to really consider what days we would go, why we would go, and like which park we would also do. Is it close? Is it not close? Again, loss of water, logger equipment. So unfortunately, throughout the parks, we did lose a few of our loggers, which was very upsetting, especially the water loggers, because we want to get the best quantifiable data, but that was not the case. And again, weather-related events, preventing survey days. So again, this summer we had a lot of like rain and extreme heat, which signified, well, for rain, not many people would want to go out into a park in the rain. So that was one option. Extreme heat, it was just not safe for us to go out. And then at some point we did have Canada wildfires, which meant nobody should have really been going out in the field. So those were a few of our like challenges, honestly. But we made do with what we had, and we continued on. Many setbacks. Again, in small parks, there are not many individuals that would like to partake in the survey. Again, not entirely our fault. We can also force people to take our survey, but we tried the best to our ability, and we actually did get a few surveys at these smaller parks, and they actually did make a difference. Also, some parks have communities that don't speak English or Spanish, so it could be very hard for them to take a survey. In Kaiser Park, we had a lot of Russian speakers, and in McKinley Park, we had a lot of Chinese speakers, so we really couldn't bridge the gaps between the language barriers, so that was another setback for us. Preliminary observations. So again, with the data being limited, with some of our loggers being taken away, it's hard to really collect and observe the data, or at least compare them to one park as opposed to the other. So in one park in particular, which was SoMAS Park, like in Crown Heights, we basically lost all of our loggers except for one. So that was really hard for us. So as we traveled to multiple parks, we've noticed the effects of climate on parks alone. So the image I actually took here is of Marine Park, which is one of the many parks that are part of marshlands. We did obviously community service there. We have our loggers there, and we actually have a few loggers in the marsh, for example. I don't know if you guys can see, but the tree roots are being basically held by nothing. Like there's very little ground in that marsh, suggesting there's been a lot of erosion. The marshes are obviously essential for the park community, not just obviously for the people, but also just for the ecosystems that live there. If this tree, is barely hanging on by a thread, that just shows how bad the climate has been in general with flooding and everything going on. So the significance and impact, again, this is the first study of its kind. It's both examining social and ecological climate resilience in Brooklyn parks. It also evaluates how green spaces may help address flooding and extreme heat. Coastal nature-based infrastructure, again, allows to absorb and retain floodwater. It reduces the impacts of flooding, and it protects coastal ecosystems and habitats. Again, marshes face threats from inundation, erosion, sea level rise, and habitat loss. Findings could eventually help identify where resilience improvements and park improvements may be needed. And again, long-term research could help support public interest policy decisions and future funding. The significance of the study, and again, our final concluding statements. This pilot helped us establish and learn about how to continue collecting data across different parks and neighborhoods, how to improve sampling, monitoring methods based on the pilot experience, obviously, how to use future data to identify where green spaces improvements may needed to be, help understand how parks can respond to heat, flooding, and other climate events, incorporating community experiences into future resilience planning. Obviously, there's differences between park environments and people, equipment and logistical limitations again, ways to improve future data collection, and a foundation for a longer NBSI research and study.
We have time for a few questions. Oh,
Hi, Adrian. Do you think, thinking about how this could be improved in the future, great job here. So I think some of the language difficulties, there are other people in the program who speak Chinese, for example. I don't know about Russian, that might be really hard.
Yeah.
Did you consider offering just some little thing to people if they took the survey?
I mean,
Like a hat or a sticker.
Yeah.
Or
Yes.
something like that, like
Yes.
comes to the food.
So again, in the image of tabling, I don't think we had the photo of our QRs there, but we obviously have our QRs that sends us to the link of our website. Obviously, we only have the English and Spanish version, but I feel like if they were just scan the QR code and then translate it, they could obviously take the survey there. Even in situations where some people just couldn't take the survey because they were too busy, we made them scan the QR code and they would just do it on their phone, maybe while they're taking a walk or walking their dog, for example. So we tried to, even if they didn't speak English per se, we still try to encourage them to do it, even if they had to get a way around it. But yes, we would hope to.
What about offering something?
We would offer stickers even then, because there are some people that still try to take the survey even with the language barrier. So we still try to encourage them the best way possible. Again, not trying to discourage them at all. Be like, hey, yeah, you're still doing something great for us, and we appreciate everything that we do. So here, take this.
And
When you say those sensors were lost, you think they were stolen or they just don't function or what happened?
This is our leading theory, and again, take this with a grain of salt because we don't even know. But we're assuming the parks people have been either taken them because at first we thought it was people, but the more we really thought about it, especially because the parks people are so like ruthless of like not having stuff like hanging around or like having just stuff in general, like in their parks, you know, they want to maintain them, keep it clean, subjective. But we're assuming it was actual parks people taking our loggers, and again, I completely take it with a grain of salt because I could be wrong. But that's our leading theory.
They were just gone.
Yeah, they were just gone. We looked for them. We tried to look for them. We did actually manage to find one of our tags that was connected to the logger on the ground, but the logger was just gone. So
For the folks that had language barriers, did you quantify any of that? Like what percentage of people at some of these sites were having that issue with taking the survey?
no, but we did keep in mind of like the communities, like, you know, there was multiple people that spoke Russian. We're like, okay, we're in the Russian community, you know. So again, like I mentioned before, the Kaiser Park community, that was mainly Russian, like we had Ukrainian people as well. And even then, even for some of the language barriers, they would still tell us like their stories about like, oh, how long they've been living in the neighborhood, you know, how did they get here to New York City? So it was really like eye-opening because you got to know about like the different communities within Brooklyn. That's how you figure out, okay, this is how we know there's, you know, this Russian community here or there's Chinese community here. It was a learning experience, that's for sure.
I have a question for you. Did anecdotally, obviously, because this is not, you know, you don't have anything quantified yet. Did you find that the people who did the survey recognized an issue with flooding or were concerned about an issue with flooding in their area? And did they have any ideas of what they wish would change?
Yes, actually, I think it mostly depended on the park we went to. Again, if you saw the map, it was like a lot of like southern Brooklyn, so the Coney Island area and all that type of stuff. And so when we took surveys there, those people would actually tell us about their experiences, not only with Sandy, but like with current flooding events now. So they're like, yeah, I remember when this happened to us and so on and so on and so forth. So I feel like people were just very encouraging of like, oh, they're doing great for the park. And then I feel like once they also realized that we were from Stony Brook, they actually got more encouraged to actually help us and like participate in the survey. I also want to keep in mind that, excuse me, for the tabling image, before we didn't actually have like the Stony Brook like lettering and tarp. So before it was like I feel like really hard for us because it just seemed like we were just a group of kids just tabling. And then once we finally actually got the Stony Brook like lettering and you know we were actually part of the department, I feel like people once they take us more seriously, but they were more inclined to be like, oh, okay, they're from a university, you know, and we're actually taking data and so on and so forth. And then we were more inclined to actually take our surveys.
Thank you, Adrian. All right. Up next is Marissa McKiernan, and her talk is titled Go Slow, Long Island, Educating Boaters on Sea Turtles, Vessel Strikes, and Other Fishery Interactions.
Good? Yeah. Okay. Hi, everyone. My name is Marissa. I did my internship with the New York Marine Rescue Center. My project is titled Go Slow, Long Island, Educating Boaters on Sea Turtles, Vessel Strikes, and Other Fisheries Interactions. My Stony Brook mentor was Dr. David Taylor, and my Rescue Center supervisors were Emma Hahn for education and Maxine Montello for data and research. A quick outline of this presentation, I'm going to go over some background information, talk about my project, some of the data that I looked at, my recommendations for the future. I'm going to acknowledge some really cool people, and then I'll open up to questions at the very end. The New York Marine Rescue Center is New York's primary responders to sick and injured seals, sea turtles, and small cetaceans. They're located in Riverhead, New York, just behind the Long Island Aquarium, where they have a facility equipped to rehab seals and sea turtles. And their mission is to preserve and protect the marine environment through conservation efforts, including rescue, rehabilitation, education, and research. Go Slow Sea Turtles Below is an education campaign that started in 2023 with the goal of educating boaters on vessel strikes and fisheries interactions. It is held at local marinas across Long Island during the summer months and is led by volunteers. Here in New York, we have 4 species of sea turtles: the loggerhead, Atlantic green, leatherback, and the Kemp's Ridley. And just some definitions to know for this presentation. Vessel strikes are when a marine animal gets struck by the hull or propeller of a boat. Entanglement is when they get tangled in inactive fishing gear. Bycatch is the unintentional capture of a non-target species. Hooking is when a sea turtle is caught with a hook and a line, and the hook could be embedded anywhere externally, whereas ingestion, they usually swallow the hook and it's embedded internally. And then just a quick warning, the next slide does have a picture of a dead sea turtle on it. So on the left here, we have a picture of a loggerhead that was struck by the propeller of a boat. You can see the laceration going straight through its face, the side of its head, kind of down its shoulder region onto its carapace. And then on the right, we have a picture of a leatherback that is entangled in rope. So my project goals were to improve the Go Slow campaign by adding marinas to the 2026 calendar, increase the donation intake from previous years, and to determine if there were any areas that we should focus future efforts on in trying to get events held in those locations. To do that, for adding marinas, I contacted all of the previously participating marinas to see if they wanted to continue working with us on this. And then I took to Google, basically just searching like boater events on Long Island this summer, trying to find new marinas to add to the list. To increase the donation intakes, I added donation encouragements to the table. So for example, one sign said it takes X amount to rehab one sea turtle. I added the QR codes for the rescue center of the Venmo and PayPal accounts so that people had more means of donating than just cash. And then I also created a fundraiser thermometer so they can see where in our goal we are. And then finally, to determine problem areas, I looked at 15 years worth of vessel strike data with sea turtles to see if there's any emerging hotspots that we might need to pay attention to. And I just want to make a quick comment that these issues face all types of marine animals, marine mammals, but for the sake of this project, I just looked at sea turtle data. So the first thing that people see when they walk up to our table at a marina is the Go Slow campaign flyer and our strategies on how to try to avoid interacting with marine mammals on the water. The first thing that, the first talking point would be to wear polarized sunglasses. It kind of helps you see underneath the water a little bit better. And I always like to make a joke with people, like if you're looking for an excuse to buy a fancy pair of sunglasses, this could be your reason why. I'd usually get a couple of chuckles with that. Appoint an onboard marine animal spotter. That was usually a hit with the kids because they felt like they could participate. Look out for blooms of jellyfish and steer clear of sea turtles. Don't expect them to move out of your way because they will not. And as always, stay 150 feet away. These are some of the things that we had at the table. So on the top left is our donation incentive. These are foam keychains that were left over from previous years. We did have a very limited number of them. So anyone who donated $1 or more was offered a keychain. On the bottom left, we have the Rescue Center business card with the stranding hotline number on it, as well as our sighting card that has pictures of the seals and sea turtles we see here in New York with just descriptions of those animals. Next to it, we have 2 case cards for Coconut and Chestnut, which was designed by Emma previously. And both Coconut and Chestnut were victims of a vessel strike. Both of them were successfully rehabbed. Coconut was released last year, and Chestnut actually ended up having some buoyancy issues. So she is our current resident and is non-releasable. So this was aimed for kids. They like taking it and learning about the sea turtles and stuff like that. And then I wanted to try and add something fun, another freebie that people can take. I'm a big reader. I love reading, and I know that a lot of people like to read out on the boat. So I shrunk down Coconut and Chestnut stories, and then also these strategies on how to avoid a vessel strike, and made a double-sided laminated bookmark with the stranding hotline on the back. And that was also a hit, which I was happy about. Above that, we have the fundraising thermometer that I made. I designed it in Canva, and after 2 events of having it, we reevaluated and actually decided to up our goal. Here you can see the evolutions of the Go Slow table. So the first picture was our very first event. Not all of the events are pictured, but we asked people for some feedback on how we can improve the campaign while we were at the marinas. And a lot of them just said that the table was a little overwhelming to come up to. There's a lot going on, a lot of flyers. So over time, I requested a larger table. I reevaluated all the flyers that were on it. I grouped things together so that they were similar things were in similar areas, and also made sure there was a lot of white space in between things on the table so it just wasn't so overpowering. And in that last picture, you can see 2 of our lovely volunteers that came to help out. And a result for the Go Slow events themselves, so far we have attended 8 events. We have 1 left this weekend. We've raised $650 so far, which is an increase from last year, and we have educated 102 boaters. The locations that we went to this year were Mattituck, Southold, Hampton Bays, Eastport, and Babylon. Now I'm going to talk about some of the data. So I made a spreadsheet of all of the fisheries, or all of the sea turtle fisheries and vessel strike interactions from 2010 to 2025. This graph just kind of shows everything grouped together, so you can see that there's a general increase in occurrences from that time to now, a lot of them being vessel strikes. From there, I wanted to see what the mortality looked like, how many turtles are surviving versus how many turtles are not surviving. And as we can see, boat strikes have a very high number compared to the other interaction types, and majority of those are deceased. In this graph, I was curious to see which species of sea turtle are affected the most by vessel strikes. And for the first one, the loggerhead, it had 95.8% of sea turtles die. For the Atlantic green, 85% died. For the leatherback, 100% died. And for the Kemp's Ridley, which is the most endangered sea turtle, 94.7% died. Next, I took all of the vessel strike data and I uploaded it into ArcGIS, where I made a heat map. So here we can kind of see all of the spots where there were vessel strikes in blue, but any areas that had a high density of occurrence, that's where it starts turning into red and even yellow. So here we have higher densities of occurrence happening, and then here we have a very high density starting to turn to yellow. So from there, I ran a hotspot analysis to see if any of those denser areas have a pattern, and majority of, actually pretty much all of Long Island came back as not significant, except for this one area here, which is actually, this here is Staten Island, and then here we have Brooklyn. So as you guys can see, we have 99% confident hotspot in Staten Island, moving up to 95 and 90%. I also went ahead and found some ferry routes and marine highway data sets to add to kind of see where everything was overlapping. So I would probably say that a lot of the vessel strikes are happening out in this general area where all of that traffic overlaps. And then since the majority of the turtles are found dead on shore, they probably just washed ashore after. So conclusion for the data section, vessel strikes are a growing case of concern. We did know that. That's one of the reasons why we have this campaign. Loggerheads are seen to have the most vessel strike cases, whereas leatherbacks have the highest mortality. I think that's really good talking points that the volunteers could have at the table when they talk to voters. And Staten Island and Brooklyn are emerging hotspots. My recommendations for the future are to start reaching out to marinas earlier in the year. I found that a lot of marinas have events for customer appreciation, food truck events, boater festivals, or live music, and they'll have them earlier in the season, right before summer starts. So I think if we reach out to them sooner, try to get to those events where they're going to have a high boater turnout, we could reach a lot more people. Take advantage of marinas that are willing to host again. A lot of them were like, hey, if you want to come back another day, just call us when you're on your way and let us know, which was very appreciative. We were very happy with that they were willing to do that. But I think it would be good to try and get some new marinas in there. And then once we kind of, have a set schedule, we can fill in the rest of the calendar with marinas that maybe we already scheduled once for that summer, and then we can add them in again. For the table itself, I would take away some of the flyers that maybe aren't as specific to this campaign and replace it with things that are, such as if we pull an entanglement mass off of a turtle and it's all of this fishing line and all of that stuff. Having that on the table might be great to see. Another thing I think would be really beneficial is if we can preserve a carapace of a sea turtle that had been struck by a propeller, where you can see the lacerations. I think having that on the table would stick with people, where they can see it and touch it way more than anything I could ever actually say to them. And then finally, try to add events to the Staten Island and Brooklyn areas. For the acknowledgements, this project could not have been possible without the support of the New York Marine Rescue Center. Maxine, Emma, Riley S., and Andrea, thank you so much for helping me with this project. The staff members, everyone else, just for always being so supportive of me when I was a volunteer. To the volunteers who came out and helped me at the Go Slow events, Rob, Esme, Ada, Ann, and Cameron, thank you guys so much. For Stony Brook University, my mentor, Dr. David Taylor, for Dr. McClenachan for answering questions about ArcGIS, and for my advisor, Kaitlin, who has probably answered 1 million emails this year. We really appreciate you. And finally, I couldn't have done anything without the support of my family. They've supported me throughout my entire life, but especially when I decided 4 years after graduating an out-of-state school that I wanted to completely change my career field and go back to school 10 miles down the road. I love you guys and thank you so much for all of the support you have given me. This here is the New York State Stranding Hotline. I highly recommend, if you don't already have this saved into your phone, please save it now, especially the field that we're all going into. Future MCP students, definitely save it because at some point you're going to be out on the water or on a beach, and it's really good to have this number saved into your phone. With that, I thank you guys all for listening. Does anybody have any questions? Yeah, Adrian.
So as someone who's also done tabling, I instead started like very like, I wouldn't say bare bones, but it's more like a learning experience, once we got our table mat, a bit more professional. For you, what do you think was the best thing that would like be like, obviously you said at first the table was a lot. So once you, I guess, like figured it out, what was the thing that caught people's attention the most, or like actually helped you get people to
come up?
Yes.
So it's kind of backwards from what you would think. The more we tried to get people to come over, the less people would come over. So we would kind of stand there talking with each other, me and the volunteer that was helping me. And usually that's when people would start coming over, because I think it was maybe low stakes. We would always, as people were walking by, we would always just give them like a good morning or hi, how are you type of thing. And then usually they would come back and come over. The only time we really had people like not come over and kind of do like this as they were walking by was when we would try to be like, hey, you want to learn about sea turtles? And they would be like, no, apparently. But yeah, so I think in the beginning, maybe with the table being so small and so crowded, because we had things from Go Slow, current events of the rescue center, we just had a bunch of just general information also in there. I think taking some of it away and laying some of it down flat so that it wasn't all like stacked next to it, it was just a little less overwhelming to walk up to. We did have the tablecloth with the rescue center logo on it, so I think when people see the like medical symbol with the turtle and the seal, some of them are just naturally curious. So yeah.
Okay. Sorry. So who is your primary audience?
Boaters. Yeah, so we were boaters. So we were at local marinas, and we were mostly trying to talk to people who were going out to their boats. So that they were, and we talked so the campaign mostly talks about vessel strikes, but we did kind of talk about, like don't throw your fishing line over, your nets over, stuff like that, to just guard them, make sure they get thrown out properly and stuff like that. And usually the conversations would kind of just take, we had a couple people who have houses in Florida talk to us about the nesting and stuff down there. So some people knew like stuff that was going on, but it was mainly the boaters that we were trying to talk to.
And is it enough really for them to just go slower?
So if you go slower, you have more time to react. So if you reduce your speed in certain areas, if you see a turtle coming, if you you always have to make sure you're the one moving because the animal's not going to know to move. So go slow in the sense that you have more time to react is the way I take it. Yeah.
Because I know a little bit about the diversity of your interests, but also a little bit to the way you talked about the materials that you had at the table. It seemed to me you were really interested in this question of story, trying to give individuals a story, trying to loop in the potential people coming to the table, and just what role does story have in the tabling and your outreach?
Yeah, so storytelling is good in a sense where it kind of brings people in and it gets people interested. So when you start talking about Chestnut, who's our current resident sea turtle, people are very curious to hear about her story, what happened to her. People are just very curious and they like to know things about other people and other animals. We've been telling stories since the beginning of time. That's how people used to learn lessons and stuff like that. So I think we're just very curious people. And when you have the opportunity to give them exact examples, people are very, they respond very well to that. So I think Emma, when she created the stories of Chestnut and Coconut, it was probably it was pretty well received with the kids. And then I just did it a step further into a bookmark because I felt like that was something that storytellers tend to like too.
You've been having your hand up, but I should be directing.
No, so that was an awesome presentation.
Thank you.
What was it like working with the community and explaining data and science that you did? Like, did it feel rewarding
Absolutely. Yeah. It was really, I love doing my Go Slow events. I'm gonna be really sad when this one ends this upcoming weekend. But yeah, so people, like I said, usually the people who come up to you are the people who are already interested. So they were all very interested in hearing about all of the research and the numbers and stuff. The volunteers were always asking me questions because I had a couple of people who did more than one event with me. When I was like working on GIS and trying to make the map, one of the girls, 12, and her mom was with me, us two, and I would like show her the map as I was trying to make it. I was trying to explain GIS to her, and anyone who's worked with GIS, MCP students coming in, you'll have fun with that. But yeah, so everyone seemed pretty interested. The people who weren't interested just didn't come up.
Great job. All right. Make this too. There you go. It's all good. Next, we have Elizabeth Carlin talking about the analysis of migratory species detected through eDNA in Shinnecock Bay and the impact of poleward shifts.
Can everybody hear me okay? Okay. Good morning, my name is Eliza and my project is called the analysis of migratory species in Shinnecock Bay detected through eDNA and the impact of poleward shifts. I did want to extend a special thank you to Dr. Pickish for taking me on as a capstone student this summer, as well as her lab support, research support specialist, Libby, for all of her help with my project, and one of her PhDs, Natalia, who helped me get involved in the first place. So just a brief introduction to my topic. Marine conservation requires extensive ecological monitoring. And when we think of traditional survey methods, we might think of hook and line fishing, we might think of dredging, and that can sometimes cause stress to organisms or stress to the environment. Destructive to habitats can have some negative repercussions when you're working with those traditional methods. So using less invasive methods such as environmental DNA or eDNA is a great way of also surveying our local waters. So what my capstone project focused on was a 6-year eDNA data set that has been conducted through the Shinnecock Bay Restoration Program. And I selected 7 migratory species, and through their detection frequencies related it to water quality variables, as well as recent literature on poleward shifts and climate change. So what is environmental DNA or eDNA? This is the genetic material that is continuously expelled by organisms in the environment. And what we can do is collect this from either water or terrestrial environments, and we can figure out exactly what has been there or what is currently there. And through the process that I have shown in this little graph over here, for the aquatic environment, it starts with the collection of a water sample, and then we filter that and we can extract it. And then from that extraction, it will get amplified, and through a bioinformatic analysis, we can see exactly what species are in the water column through a reference database. And then we have our results. So what is the Shinnecock Bay Restoration Program, or SHRP? They are an organization that has worked out of Stony Brook for the past 14 years, working to restore the Shinnecock Bay on the far east side of Long Island. They have done this through recovering decimated bivalve populations, as well as combating harmful algal blooms and recovering degraded eelgrass habitat. Alongside all of these efforts, they conduct trawl surveys annually in the bay from July through September. And 6 years ago, they introduced an eDNA sampling as well to complement this and understand everything that we aren't possibly seeing in the trawls as well. So alongside my project, I did get to intern with SHRP, which was a lot of fun. I got to see not only the eDNA sampling, filtration, and extraction process, but I also got to work on their trawl boats and trawl surveys. So I got to learn a lot of experience that I hadn't had before working on these boats. And it was a really great opportunity to get hands-on with the waterway that I was doing this research on. So a large part of my project was doing research into what exactly a poleward shift is and current literature on this phenomenon. So when we think of migratory species and their ranges, this is going to be changing, especially with climate change. Habitats are going to become more suitable for these migratory species, and they're going to be moving to ranges that we might have not historically seen them before. So this phenomenon is called a poleward shift, where they are going to be shifting into higher latitudes from where they have been previously associated. The region that we are in, the Northeast Shelf, is projected to be one of these largely impacted areas, especially the Shinnecock Bay as an estuary, which serves as a transition zone for a lot of these migratory species because it is a sheltered body of water, and this is where they are going to be hanging out during a lot of their migrational season. And with this literature review, I was able to narrow down species from the SHRP database, which utilizes the MyFish primer for the species I was looking for, although they do use other primers during their eDNA analysis. And those 7 species were the striped burrfish, Atlantic Spanish mackerel, spots, northern kingfish, Atlantic needlefish, sheepshead, and Atlantic croaker. So these are all local species. They're migratory in our waters. To give you an idea of how north some of these species can be found, I went on iNaturalist, and then on ArcGIS I produced this map of the most northward reported observations from in between 2020 and 2025. So you can see some of these species are found all the way off of Cape Cod. Meanwhile, on iNaturalist, Atlantic croaker was only encountered off of Long Island. For my data analysis, I used existing data from in between 2020 to 2025, which had already been processed. And I combined all of these sample data from either the water quality or the eDNA sample, and I put it onto one spreadsheet altogether, marking the species as detected and non-detected using a 1 or a 0. And then the detection frequency that I used for these species was calculated monthly by using the number of samples that were taken each month and how many times each species was detected during that month. To visualize all of this detection frequency, I used a bubble plot. So you can see here that spot had the highest detection frequency. It had 100% in 2023, which I will talk about a little later. Northern kingfish also had one of the highest detection frequencies in the data set. Meanwhile, sheepshead and Atlantic Spanish mackerel had the lowest in the data set, and Atlantic croaker was not detected in any eDNA samples. For the water quality data, which is collected through a YSI during the time of sampling, I created a 3-panel line graph so we can see those averages throughout the year, or rather the sampling months, and the averages are represented each by a dot. And that YSI is collecting dissolved oxygen, salinity, and temperature, which we are writing down at the time of sampling. I did produce these individual line graphs for each species, but for my overall capstone, I did only focus on 3 because they had the most years and months of available data. So for spot, like I said, its highest detection frequency was in 2023, where it had a 100%. It was found in every single sample. And then in years when October and June were sampled, in June of 2024, spot was detected. Meanwhile, in October of 2021, it was detected as well. Northern kingfish had its highest detection frequency in September of 2021. And then in the rest of the years of the data set, or 2021 as well, we can see that it was pretty steady in August, a pretty consistent rate of detection frequency. For the striped burrfish, its highest detection frequency was in June of 2024, and then the most recent occurrence of striped burrfish in eDNA was in September of 2025. I also wanted to visualize these species from the trawl surveys. However, only 4 of the 7 selected species from the eDNA were encountered on these trawls. However, Atlantic croaker, which was not encountered in any of the eDNA, has been seen on these trawls. So spot and northern kingfish also had the highest catches out of these species on the trawls. So just a little bit of a breakdown of my results is that the detection frequencies for each species did vary very much throughout the data set because they all respond differently to different environmental variables, and I'll get a little bit more into the limitations in a few minutes. But sheepshead and Atlantic Spanish mackerel each occurred only once during the entire data set, and that was in August, when the water had generally higher dissolved oxygen at the time of sampling. Atlantic needlefish also had its highest detection frequency when the water temperature was the highest in the data set. And then from the individual line graphs, spot detection showed a possible relationship with water temperature. The years when we sampled June and October, they were only detected in years when the water temperature was higher than the year that it was not. So we can see that this is a possible relationship. And then northern kingfish also showed a possible relationship with higher salinity, similar reasons as the spots. And then striped burrfish did not exhibit any substantial relationship with any of the water quality variables that I was looking at for this project. And then once again, Atlantic croaker, despite not being detected in any eDNA, it has been detected in recent years of trawl. And the spot and northern kingfish, although they were not detected in trawl, or they were not seen in trawls in 2020, they were detected in eDNA. Although this is not a substitute for our standard ecological surveys such as trawling or eDNA, we can use local and anecdotal knowledge to understand these shifts in our waters and changes of certain species that we're going to be seeing. So for example, there has been an increase of catches of mahi-mahi off of Long Island. This little fish over here was actually caught right off of a dock. And this is more associated with subtropical waters, so we can see changes just through fishing and those types of communities as well. And then also blacktip sharks, which are also more commonly associated with warmer tropical waters, are being more commonly seen off of Long Island as well. And that iNaturalist that I use for the map that I produce is also a great way for us to see exactly what is being seen in our waters today. Some of the limitations of the research had to do with YSI variability. It is all taken at a single point, so this isn't a projection of the entire day or the entire month. And then the MyFish primer is designed to detect a broad array of species, so this can limit some of the sequences that we are seeing. And then site fidelity for certain species is another thing to take into account. Although we are sampling a lot of the bay, it does not eliminate the fact that there could be the species there. We're just not sampling the spot that they are currently in. And then this is a limited data set. Since I was working with 6 years of data, you would need more of a long-term data set to really make solid projections. And my conclusions are that this capstone evaluated whether patterns in the eDNA and frequencies did align with poleward shift literature. And if these comparisons between eDNA and trawl catches were there, we could see that there were some similarities for certain species, but also differences for others. And my main takeaway from this project was that continued monitoring is very important to understanding how species are going to react to certain changes in our waters, especially these poleward shifts and other types of stressors. And if we continue to combine eDNA monitoring as well as public accounts and trawl surveys, we will begin to learn more about what these shifts are going to look like in the Shinnecock Bay. And thank you. If anybody has any.
Sample after other events or increased runoff?
Yeah, so we actually went out on Tuesday after a rainstorm to sample. So we don't really have that come in the way of sampling too much. We wouldn't go out during an extreme weather event, but yeah, we would still conduct our sampling through that. When we filter the water, all of that type of particulate matter is going to get filtered down so that we just have the DNA at the end of the extraction.
What was the time frame from sampling to results using this?
Yeah, so I didn't use any of the sampling that I did during the 2026 season. I was only using samples from in between 2020 and 2025. So everything had been processed from the year before.
Do you happen to know what the time frame is?
No, not off the top of my head.
Are you asking about the eDNA?
Yeah. Yeah, like what the
Yeah,
what the time frame is from sampling to getting a positive result. Does it take a couple of days, weeks?
So it would take a few months. So we would,
Great.
yeah, the filtering happens immediately after we collect the sample. But after that, we freeze the samples. And then at the end of the season, they will send them all out to a place called Mr. DNA. And he will do the bioinformatics for that. So yeah, it will all happen at the end of the sampling season when all the samples have been collected.
it could happen more quickly. But because the price of having a sample analyzed goes down with the number of samples. Also, we analyze our data season by season. So we save all the samples and then analyze them in a big batch at the end of the season. That's why it takes so long. But you could get answers much more quickly if you wanted to do it that way.
Did you do any paired sampling? So collecting eDNA while you were out on the trawl or any side by side?
Yeah, so they collect eDNA samples at the same time that the trawls are taking place. We'll do that right before the trawl net goes out. So a lot of these samples that are gone through for my project were also taken at the same time as trawls.
So on the trawls where you were catching croaker, we're still not detecting it?
Yeah, still not detecting it in the eDNA. Yeah.
Thank you, Eliza. Next, we have Grace Nelson talking about the alternative bait trials, Whelk behavior experiments.
All right. Hello, everybody. I'm Grace Nelson, and today I will be talking about my capstone project, which is titled Sustainable Bait Alternatives for the Channeled Whelk Fishery. These are preliminary trials to support horseshoe crab conservation. And this project was done with Matthew Sclafani. Okay. So, the channeled whelk is a marine gastropod, and this is commercially valuable to the whelk fishery. Channeled whelk are predators as well as scavengers that utilize chemoreception. And this is where it detects chemical cues in the water in order to search for prey. The whelk fishery uses baited traps to catch them. Horseshoe crabs are the main bait attractant for the whelk fishery. Horseshoe crabs are ecologically important to species like migratory shorebirds that rely on eating horseshoe crab eggs, or horseshoe crabs are also important biotivators for ecosystems. So with the harvest of horseshoe crabs, for bait and biomedical use, the populations have declined. This can impact certain species and ecosystems. So in the response to their population decline, a moratorium will begin in 2026, this year. This is a phase-out moratorium where each year the harvest percentage will be decreased until 2029. And this is where all harvests will be prohibited. So, with the approaching moratorium, this project will move away from the reliance of horseshoe crabs and to develop an alternative bait for the whelk fishery. So horseshoe crab versus alternative bait trials will be conducted to attract the attractiveness of other bait compared to the horseshoe crab. So in developing this experiment, there's also various calibration trials that were conducted. So now on to the methods. Now it's a lot happening here. But this is the chemosensory split flume tank, and this is where the experiments were conducted. So 2 of these tanks were constructed for the trials, and starting here up at the freshwater intake pipes, there's 2 of them. They will run down to the pipes located near that bait chamber, which I'll zoom into. So this water is being pumped in from Flax Pond, and it will travel down these pipes and enter the bait canister, which will hold the bait in bait bags. The water will continue down and up around the pipe into the system. But first we have the valve to control the flow, and then the flow meter will measure the gallons per minute that's pumped into the system. Bait buckets were also used. So this is just bait with water, and it is pumped into the system to have that bait sent continuously throughout these long trials. Okay, so once the water enters the front of the tank, this area is separated with a divider. The water will flow through a series of baffles and collimators, and this is to promote laminar flow. Once the water enters the choice arena, there's no more divider separating the streams. So we could see we use food coloring to visualize this split stream. So the water will flow through, and we could see that there's only minimal mixing in between the 2 different sides of the stream. We have also conducted velocity calibration trials where there's 9 different points of velocity measured on each side of the flume at 3 different depths. So this is just to create a visual of the speeds throughout the entire tank. So once the water passes through the choice area, it will dump out the end of the tank. And since we're working with a nocturnal animal, a box was constructed above the choice arena. This allowed the area to be dark throughout the entire trials. We could also see an IR light and a video camera that's attached to the top of the box, which records all the whelk's movement in the choice arena. Again, with trying to track a whelk in the dark, we had to do a few different things to test different methods to tracking it, but we landed on covering the entire whelk in reflective tape. This was so we could actually see it in the dark. So this is the display on the video camera, and these trials, again, they were ran overnight, and these recordings were then analyzed in LollyTrack. So this is kind of what the page would look like. This software, we looked at the time spent, the percent time spent, and active time in each zones that we created. So the 3 zones that I used was side A, which is the top, side B, which is the bottom, and then a buffer zone in the middle, which again, that's where these 2 streams were mixing. All right, now onto the results. I know that was a lot to keep up with, but first with the velocity calibration trials. So we did these because we felt it was important because whelk are known to be attracted to turbulent flow. So we could see here the average speeds between system 1 and system 2 are fairly similar, and this proved that we had consistency between our 2 different tank setups. Next, for the standard deviation, there was the low standard deviation shows that there's no significant change in speed throughout the entire tank, which is ideal to avoid any other variables to trigger their searching behavior. Next, we have residual bait scent trial results. So to prove that we were cleaning the tank properly, we conducted these residual bait scent trials. So first we would conduct a trial of horseshoe crab versus blank. Then we would perform these two different cleaning methods, which was a freshwater soak or Alkanox sponge bath. We can see in this graph, this is the time, the percent time spent on each side, that both cleaning methods show similar results, where the whelk was not exploring the horseshoe crab scent side. So this shows that both cleaning methods were successful, but we chose to elect the Alkanox cleaning method for these trials. And lastly, we have the horseshoe crab versus alternative bait trials. So first, looking at the spider crab versus horseshoe crab, the average percent of the time spent on the spider crab side was similar to the horseshoe crab. For scallop viscera versus horseshoe crab, again, the average percent time spent on the scallop viscera side was again similar to the horseshoe crab. These are some promising results of these preliminary trials. Next, we have clam bellies versus horseshoe crab, and the percent time spent on the clam belly side was considerably lower than the horseshoe crab. And lastly, the average percent time on the green crab side was higher than the horseshoe crab. We can see that there's a high standard deviation for this green crab samples, and this may indicate variability of preference between individual whelk. So these are preliminary alternative bait trials, but they do show some promising results that we are going to continue to test. From these experiments, we have learned so much about the system, and we do have some new methods that we would like to test in the future. For example, switching the streams of the bait to change those chemical cues and see how the whelk will react. And again, this is just the beginning for this trial, this project, but with the harvest quota of horseshoe crabs declining, an alternative bait option is crucial to the whelk fishery. And here are just a list of people that have helped us with this entire project. So thank you.
I'm perfect. I had one specifically. Were there, so I'm assuming that you picked, or the team picked the specific alternatives because one, you thought there might be a good chance that the whelk would like them, but also was there a thought of, all right, are we going to somehow now stimulate like a green crab fishery that might impact that population?
Mm-hmm. Yeah, so with green crab being an invasive, it was thought to be, okay, we could harvest these and reduce their population. With spider crab, this is not a commercial like fish to fish for, but relatively available, especially in our waters. And then with scallop viscera and clam bellies, this is all waste stream products. So this could be another way to use what is just thrown out typically. Cool. Yeah.
Thank you very much.
Thank you.
Up next is Jack Kranes talking about broodstock conditioning of Atlantic rib mussels for nitrogen bioextraction. I do not think so, only because then they will also see the presenter.
Okay. Hi, everyone. Thanks for being here. My name is Jack Kranes. My project is titled Broodstock Conditioning of Atlantic Rib Mussels for Nitrogen Bioextraction. I worked alongside my capstone advisor, Dr. Matt Sclafani, as well as the Marine Animal Disease Lab here at Stony Brook, headed by Dr. Bosmalam and Dr. Emmanuel Pils Espinoza. So just some background about what exactly this project is tackling overall. We're looking at the issue of nitrogen loading in the Long Island Sound. Nitrogen loading is the total amount of nitrogen that is entering a body of water or over a given period of time. That could be through wastewater, groundwater runoff, things of that nature. We're using we're looking at filter feeders as a partial solution to conduct nutrient bioextraction. So the removal of nitrogen at the harvest of the animal. So conceptually, bioextraction, as I said, is the removal of nutrients from the water column via the cultivation and the harvest of filter feeders. This project is based on the assessment by Gallimani et al. In 2017, talking about the Atlantic rib mussel as kind of an animal with untapped potential for this sort of practice. That's because they have a couple of really important factors for this, to conduct nitrogen uptake. They have a really high rate of nitrogen uptake. They're super tolerant of turbid and stressful urban environments. So that can be anything from really high temperature, low temperature, high salinity, low salinity. They're also used for salt marsh stabilization, under sea level rise and erosion pressure. And additionally, they're a non-commercial species. They're not consumed by the public, so there's no monetary factors at hand. So kind of identifying the bottleneck of this project, the wild harvest of an already vast population of Atlantic rib mussels in the Sound would damage the habitats that the mussels help to build up. And currently no hatchery has really reliable large-scale protocol for production. So the hatchery methods, the raising of the seed is the limiting step. So I joined this project in phase 2. Phase 1 occurred last year. During phase 1 of the project, it was identified that the primary limiting factor in hatchery production was the proper conditioning of rib mussels. Those constraints included everything from broodstock diets, algal treatments, histological diagnostic rate, things of that nature. So what we kind of honed in on as the umbrella objective of this project is to develop and optimize proper, effective, consistent rib mussel cultivation, particularly focusing on gonadal development and ripening of the adult broodstock. My daily tasks and objectives, I guess, kind of included maintaining the algal cultures, quantifying cell density for consistent feeding rations, as well as focusing on optimizing gonadal development for the three diets, which I'll get into in a second, comparing that to the wild reference animals. The next part of the next step in that process was evaluating different kind of rapid, lower cost gonad ripeness assessment methods as opposed to histology analysis. So just to get a lay of the land, we had the 3 wild reference sites that you can see are in yellow. The Flax Pond is kind of overlapping, but Huntington Gold Star, Flax Pond Inlet, and Mattatuck Creek, that's where we were going weekly to collect wild samples and then bring them back to the lab for analysis, as well as Schmelk, which is the south of the Cornell Cooperative Extension. There's a large hatchery there. That's primarily where I was stationed over the course of the summer, and the Flax Pond Marine Laboratory. Those were the 2 locations where we were conducting hatchery analysis and broodstock development. So there were 9 tanks at Flax Pond and 3 tanks at Schmelk. At Flax Pond, we had 3 different diets that we were feeding the mussels. There was a standard diet, standard and local diet, and standard microbial diet. And then at Schmelk, we were only feeding the standard diet. There were 120 mussels per tank at the beginning of the conditioning cycle, which was a 12-week period. The standard plus local and standard plus microbial diets were standard and local was a 50-50 blend of algae species, and the standard and microbial was an 80-20 blend. And again, the Schmelk diet was the standard one only. So the daily processes that I was going through at Schmelk included using the Luna2 cell count device to take samples of the different algae species, get accurate cell counts, and then using a formula created by Helman Born in 2004, using the algal dry weight and making a ration with the mussel dry weight to get the proper amount of literage for each species of algae to feed over the course of a day. So on July 1st, we raised the ration from 4% to 8% because using the wild reference animals that we were looking at and comparing them to the hatchery broodstock, we weren't seeing the type of growth that we were looking for. So as soon as we bumped it up to 8% within a couple of weeks, we were more happy with the status of those animals. This is kind of a collection of like the daily process of feeding. So On the bottom right-hand side, you can see the barrels that we would use to feed the animals. Each species of algae, when it was measured out, we would dump it into the barrel and it would drip into the tank over the course of the day. It was all mixed together in there. So as I mentioned, weekly, we would then bring the animals to the Marine Animal Disease Lab for gonadal condition assessment. In this practice, histology is kind of the gold method, the gold standard for determining gonadal development and conditioning. But over the course of the summer, we developed two rapid alternatives. So a visual scoring system as well as a QPath photo analysis system. So we had three different categories of ripeness in the animal, which I'll detail in a second, but there was just not ripe, ripening, and ripe. We capped it at 50% because anything higher than that gets kind of difficult to determine just how ripe an animal is. So we decided to cut it off at 50%, as well as the imprint blotting that we were doing, which I'll also get into in a second. You can see here the top left and the right-hand side is just some process pictures of the histological collection process, and the bottom left is my imprint blotting station. So looking at the animals, before I show you the categories, the left-hand side, you can see the females, the gonad development in the middle of the animal, the center mantle of the animal. There's a lot of brown tissue at this point. This is a ripe specimen, so it's pretty plump, and the male doesn't have that brown tissue. This is also a far along male, but that's the primary thing that we use to identify the sex of the animal. And then these were the three reference images that I used to categorize the ripeness of the animal. So you can see in kind of ascending order from left to right. On the right-hand side, that's a very ripe specimen. There's a lot of gonad development, a lot of brown tissue there. Just looking at the category 1, there's a lot less tissue on that side. So the QPath analysis that I mentioned, once I was able to go through all of the hundreds of individuals that we had over the course of the summer and categorize them just using a kind of a gross visual analysis, I then took the reference images that we were using to do that and plugged them into QPath, which is a photo analysis software. The green area you can see is the parts of the animal that are not gonad tissue. So the red is really like the quantification of how developed the animal is at the time of photograph. So before I get into the results of the development over the course of the summer, feeding protocol was something that we really wanted to establish consistently over this 12-week cycle. So we were very happy to be able to do that. Feeding protocol was consistent across both hatcheries and produced really like baseline standard consistent results for the standard diet, because the standard diet was the one that we were using at both sites. So these are some photo analysis results from the wild reference animals that we were looking at. You can see the x-axis on this graph is the percentage of females sampled, because we were just looking at females for this portion of the data analysis, and the y-axis are the dates that they were collected. The different colors that you're seeing, blue is for the not ripe animals, orange is for the ripening animals, and green is for the ripe individuals. So Flax Pond had the slowest period of gonadal advancement, and Mattituck actually had the earliest. Huntington and Gold Star was kind of variable over the course of the summer. And then getting into the nitty-gritty of the rapid scoring validation. So using the QPath photo analysis, I was able to compare the gross visual analysis that I did against software to kind of validate the numbers that we were seeing. So I took 10 images per site per sampling date and scored them in QPath with that outline that I showed you earlier. And then I compared those numbers, those scores, against the field categorical assessment and assignment that I was doing over the course of the summer, just off of the eye test, really. And there was about an 80% agreement average across the series, which is a strong number to be at. We're still waiting for the histology results are pending, and that'll be a stronger test as it relates to validating the scores. the fresh imprint blotting that I mentioned previously, the cells transferred to the slides appropriately, but the features were kind of unresolved without staining. I'm going to talk about that in the feature steps near the end, but at the end of the cycle, we were able to do a spawning series at Schmelk and at Flax Pond. We had 8 of 12 bin trials that produced successful gametes at Schmelk. At Flax Pond, the first 2 trials failed, and then the second 2 were successful. We saw that the standard and microbial diet actually gave us the highest larval counts. And the regular standard diet gave us the lowest. This graph here shows on the x-axis the larvae per 1 milliliter of sample, and on the y-axis it shows the dates that the trials occurred on. So some broader significance for this project, obviously identifying the hatchery seed development and growth as the rate limiting step for this type of bioextraction and applying that to living shorelines and restoration projects. The scoring methods that we developed could be readily used by hatcheries because they're quite fast and easy to apply to any sort of setting. The next steps that we're working towards are, as I mentioned, completing the histology and lipidomics, refining the imprint staining that we talked about, the methodology of that. And next year, the goal is to, or what will happen is the same process will occur only at Flax Pond with the best diet. So once the numbers are compared against the histology analysis numbers that we get, we'll decide upon that. I just want to give a special thanks to everyone who assisted me and spent so much time advising me on this project. Matt, Bossum, and Emmanuel, I can't thank you enough. Peter and Ashley as well for their guidance. All of the pictures as well and videos in this were done by my friend Filippo DeFranco. That he created a short video for me as well. If anyone is interested, there's a QR code here that shows the whole thing. Very grateful for that. Yeah, that's it. Thank you.
It's time for like baby to breath.
When selecting the mussels that you were going to measure the gonad for, how did you select which ones? Like, was it a size that you were looking for on the exterior?
So for the visual analysis, every single mussel that we collected and every mussel that we were both wild and hatchery, I did the visual analysis for. The QPath analysis to validate those numbers because of a time crunch, I just selected like the 10 from each date at random without identifying the numbers. I just pulled them from the folder and went off that to get some sort of validation process going. But it was so many pictures, so unfortunately we couldn't do every single one.
Great, thank you.
The mussels in the pictures looked really, really green compared to mussels that I've seen. They're usually like yellowish. Is that because they were being fed purely algae?
Honestly, I think that might have been like the glare of the screen.
Okay.
The males especially are really like almost bright yellow.
Yeah.
These ones, this species, it's non-commercially, so it's nobody's eating them. They're a lot bigger, and they live in like the intertidal zone. You don't find them on like docks or anything like that. So they're really like buried in the mud, and I believe that they become that color due to like just really high levels of sulfur intake as well. So I think they get that yellow green color. But the males are definitely like super bright yellow.
Thanks, Jack.
Yeah, thank you.
Up next, we have Sarah Langsdorf talking about tracking of Caribbean coral reefs for conservation and restoration. Yes. Help you like.
Hi, my name is Sarah. I did my internship with NOAA's Southeast Regional Office in Florida, and my project was titled Tracking of Caribbean Corals for Conservation and Restoration. So in the past 50 years, Caribbean corals have seen significant declines due to stressors such as disease, pollution, storm damage, algal competition, and ocean warming. Coral reefs are of ecological and economic importance because they provide habitat, protect shorelines, and contribute to the economy through tourism and fishing. They represent less than 1% of the sea surface, but are home to 30% of all marine species, which is about 93,000 species. And the goal of my internship was to summarize Caribbean coral restoration data from 1993 to 2025 in order to determine the scope of restoration efforts and improve the understanding of coral populations. There are currently 7 Caribbean coral species listed under the ESA. Acropora palmata and Acropora cervicornis were listed as threatened in 2006, and then the other species were listed as threatened in 2014. And Dendrogyra cylindris, which is in the top right, was reclassified as endangered in 2025. None of the species listed in 2014 have a recovery plan, which is partially because the implementation of the actions from the Acropora recovery plan will benefit these species, but also because the Acropora recovery plan was not published until 2014, even though they were listed in 2006. So creating the recovery plans does take quite a long time. And then the Acropora recovery plan includes things such as improving the understanding of population abundance through monitoring and enhancing populations through restocking. But recovery from population declines for all of these species is a challenge because they have low recruitment rates of larvae, which is due to the low abundance of adults. One of the major stressors in the Caribbean region is stony coral tissue loss disease, which was first documented in Florida in 2014 and the Virgin Islands and Puerto Rico in 2019. The disease affects 23 species of stony corals and causes tissue loss lesions, although most of the lesions don't look the same, which makes identification difficult. The disease can be transmitted through direct contact or exposure to water or sediment that has contacted a disease colony, which is a huge obstacle when it comes to controlling the spread of the disease. And the pathogenic agent is still unknown, and the only effective treatment is antibiotics. And then the second major stressor in the Caribbean region is climate change, which is leading to warmer ocean temperatures and causing coral bleaching. During coral bleaching, the symbionts that reside within the coral tissues are expelled, and the coral can survive if the symbionts return, but they'll end up dying if they don't get the nutrients that they need. Coral bleaching occurs when the water temperature is 1 to 2 degrees Celsius higher than the average for at least 1 month. And in 2023, there was a severe marine heat wave across the Caribbean region, which caused 97.8 to 100% Acropora mortality in the Florida Keys National Marine Sanctuary, and a large percentage of these colonies were restored outplants. And during this heat wave, the water temperature was above the average of 30.4 degrees Celsius for 2 to 3 months, which is much higher than the 1 month that is needed for the corals to survive. So moving on to coral restoration, early conservation efforts were focused on reproducing corals for population enhancement, but recently the focus has shifted to preserving existing genetic diversity and doing research for disease resistance and enhanced resilience. Each Caribbean U.S. jurisdiction, so Florida, Puerto Rico, and the Virgin Islands, have all created region-specific restoration plans. And restoration is really driven by 2 main factors: coral nurseries and then outplanting. The coral nurseries are used to propagate colonies that are outplanted to coral reefs, and then they're also used as gene banks. And outplanting corals increases chances for reproductive success by increasing coral abundance and genotypic diversity. So moving on to what I did for my internship, I first began by entering data that was reported from various coral restoration organizations into NOAA's coral restoration database. And as I mentioned before, the geographical areas for this are Florida, Puerto Rico, and the Virgin Islands. The coral restoration database was created as a way to compile data in a central location because there's an extensive amount of corals being outplanted and there is a wide variety of organizations involved. The database keeps track of both corals in nurseries and outplanted corals, and information reported includes location, genotypes, the number of individuals, the size of corals, and then for outplanting, it's pretty similar with the date of the outplanting and then the presumed genotype and number of coral colonies outplanted. In order to summarize and analyze all this data, I created tables for each region, and then using ArcGIS, I created maps displaying locations of nurseries and the number of outplanted coral colonies per reef. So the main product of this internship was a NOAA technical memorandum titled Caribbean Coral Outplanting in U.S. Jurisdiction from 1993 to 2025. The report details background information about coral population declines and the ESA listed corals, and the methods used to analyze the data from the restoration organizations. Currently, there are 15 organizations operating coral nurseries, and the majority of them are operating in Florida. There are two types of nurseries. There's land-based, which are the blue dots, and then ocean-based, which are the pink dots. Each nursery holds a variety of coral species, ranging between 7 species and 32 species, and hundreds of thousands of coral colonies have been outplanted since nursery efforts began in 1993. The nursery operators want to outplant as many genotypes per site as possible because it preserves genetic diversity and helps prevent any future inbreeding when the corals end up spawning on their own. To date, approximately 3,000 genotypes have been outplanted, which represents 43 different coral species. Between 2003 and 2025, more than 580,000 colonies have been outplanted in Florida. The Virgin Islands began their outplanting a bit later in 2012 and have approximately 67,000 species. And then Puerto Rico began their outplanting the earliest in 1993, and they have outplanted approximately 176,000 species. Across the U.S. jurisdiction, the most popular species for outplanting has historically been Acropora cervicornis, because it was the main focus of early restoration work. But more recently, the focus has shifted to producing more Acropora palmata, so it's expected that these numbers will start to, the Acropora palmata numbers will start to be higher than Acropora cervicornis, which is already seen in Puerto Rico. And then the shift is likely due to the intense loss of Acropora palmata during the marine heat waves and the substantial decline of species susceptible to stony coral tissue loss disease. So if you look at the table on the right, you can see that until about 2021, only really a few species were outplanted, which would be the Acropora species. And then once the nursery started propagating more species, they started outplanting them after stony coral tissue loss disease. So in Florida, corals were outplanted on a total of 247 reefs from Fort Lauderdale to the Dry Tortugas. Most reefs have received between 101 and 500 outplanted colonies, although there are some that have more than 10,000 colonies. But since there are so many reefs in Florida, the density is pretty high in most areas, so that's good for restoration. The reef with the most outplants in Florida currently has more than 59,000 colonies. And then in Puerto Rico, there are 59 reefs that are currently being outplanted on, and most reefs have fewer than 500 colonies, but again, there are a few that have more than 10,000. In the U.S. Virgin Island, there are 58 reefs. Most have less than 500, so there is work needed in this area, but again, it started much later than Florida and Puerto Rico, and the highest number of outplants is off of St. Thomas with 18,500 coral colonies. So the broader significance of this internship is that the coral restoration database is an important management tool because it provides a central location for keeping track of the thousands of colonies that have been outplanted and raised in nurseries. Under the ESA, evaluating the population status of both Acropora species is required, so entering and summarizing this information aids in meeting the requirement. And then the data summary created from this internship can provide managers with information about the scale and distribution of restoration efforts, which is especially important for the ESA listed species because it can aid with identifying priority restoration sites and creating population estimates. And then the figures created from this work can provide managers with visualizations of restoration progress over time and can help identify restoration hotspots and gaps in outplanting and which areas may need more information and attention. And then I just want to say thank you to Dr. Allison Moulding, who was my advisor at NOAA, Dr. David Taylor, who was my mentor here, and then all of the organizations that submitted their restoration data.
We have time for a few questions.
I've read that, like general Caribbean reef genetic diversity in coral is much lower than other regions of the Indo-Pacific, which is what makes it more vulnerable, like bleaching stony coral disease. I know you talked about like preserving the existing genetic diversity, but do you know if there's any effort either just between these US sites or maybe organizations site in the broader Caribbean to try to increase that genetic diversity between these populations?
Yeah, so they are trying to move some of the corals from like Mexico regions into like the United States jurisdiction, but it hasn't been largely successful because a lot of the outplants are dying from the stressors. But I do know that they are doing some breeding in the nurseries between different regions to try and increase that diversity as well. So, but they haven't outplanted any of those ones yet, so they don't know if they're going to be resistant to the heat or stony coral tissue loss disease.
How was it working on a technical memorandum with NOAA?
It was fun. It was a lot of work though. And there aren't a lot of people in the office right now, so that was challenging as well.
Thank
you. Next, we have Kathryn Maio, examining rescue efforts of pinnipeds in New York State.
Hi, everyone. Can you hear me? Okay, cool. My name is Kate Maio. My project I did with the New York Marine Rescue Center during my internship is titled Examining the Rescue Efforts of Pinnipeds in New York State and a Focus on Harp Seals. So a quick intro into my physical internship. I interned, like I just previously stated, with the New York Marine Rescue Center and stated by my classmate and colleague, Marissa, before. The New York Marine Rescue Center is a 501c3 nonprofit organization that serves as the primary response effort for stranded, sick, or injured marine mammals and sea turtles in New York State. And my responsibilities as an intern there was with the rescue team, and some of the things that I did pictured here and over here was the rescue team's mission dedicated to the rescue, rehab, and release of stranded marine mammals and sea turtles in New York State. In my time there, I worked closely with 2 species of seals, being the gray seal and the harp seal, which I'll be talking about today, and 3 species of sea turtles, the Kemp's Ridley and green and loggerhead turtles. In my internships there, some of my day-to-day responsibilities was to aid staff biologists with routine physical examinations, monitoring vital metrics, measurements, other metrics, and tracking patient recovery records through those exams, helping staff administer prescribed treatments, medications, fluid therapy in emergency situations, and helping formulate species-specific diets to meet patient and animal-specific needs. And assisting vet teams during tagging and releases with the hopes of tracking post-release survival. So in my project, I focused on harp seals specifically, partially why I found them more interesting than some of the other seal species that we see along these waters. I chose some of these pictures for this slide specifically, as you can see behind my friend Jasper up here. And in that picture in the corner, these seals are an Arctic species, so they need to be iced more when we have them in-house and rescuing them in the field than our other species that we see in-house. And a little bit more about these seals is that they are an ice obligate foetid species, which means that they come from Arctic regions. The northeastern Atlantic seaboard is actually the southernmost point of their yearly migration. Harp seals possess dense subcutaneous blubber and countercurrent vascular networks optimized for extreme polar heat retention, basically meaning that they're at higher risk of hyperthermia. Think of it as the opposite of hypothermia. They get really overheated and they can't really expel that heat very well biologically. Unlike their close related cousins, harbor and gray seals, harp seals lack mechanisms to shed internal heat on sandy beaches, or in my project, I focused on how the longer transport physiologically affects them. Segueing into that, capture and travel triggers sympathetic nervous system activation, basically meaning it spikes their heart rate, and that drives rapid core body temperature elevation. So some of my research objectives was to look at reasons why they are stranding during late winter and early spring seasons, which we refer to at the Rescue Center as our seal season, and identify primary stressors of stranding, reasons why they're stranding, and from that, analyzing 5 years or seasons from 2022 to 2026 of rescue records from the mastering stranding list, and also measuring transit distances from site of rescue to the distance of our facility in Riverhead. And from that, evaluating how that travel, depending on how long it was, affects each individual and if there is a difference between a harp seal or another species seal because of their Arctic focused biology. So looking at intake weight, body condition, body temperature, and initial blood parameters that indicate stress, and correlating if these stress indicators have something to do with how long they've been in transit, focusing on initial biomarkers, like I said before, and ultimately seeing if there's a correlation between release and mortality for those longer transit distances. So some of my methods was reviewing the New York Marine Rescue Center's master stranding list, which is every single patient that the Rescue Center has had in-house or just responded to in the last 30 years. I focused on 5 seasons of data from 2022 to 2026 in that seal season stranding window, and where they stranded and how far away it was from the Riverhead facility, calculated in miles and kilometers. Here you'll see I have them mostly in miles. And additionally, looking at each individual patient file from every harp seal throughout that 5-year period, and looking for initial reasons of stranding, body condition scores, like I said previously, like signs of dehydration and rectal temperatures, and initial blood panels if they show any signs of stress due to transport strain. So looking at results, I analyzed 23 harp seals from the years of study, 2022 to 2026. As seen in figure 1 in the graph here, looking at patient stats, we see a strong baseline success rate of 81% of harp seal patients being successfully rehabbed and released back into the wild. Non-release outcomes account for 19%, which includes individuals that unfortunately died in care or required humane euthanasia, which unfortunately does happen sometimes. And while dead on arrival or flushed patients, meaning that they retreated back into the water when New York Marine Rescue Center staff biologists arrived on the site of rescue, accounted for 8.7% of patients. Shifting over to geographic distribution in figure 2, majority of strandings occurred in Suffolk County with that high bar of 78.3%. Nassau County follows with 13%, and one individual actually did strand in Staten Island, Richmond County to be specific, and one individual was a Delaware transfer from out of state, accounting for that 4.3%. As you can see, Suffolk County heavily highlights a high stranding hotspot for these seals. And just some closer up numbers, as shown in this table, 95.7% of these cases were juveniles or pups. Most likely because, like I said previously, this is the southernmost range of their geographic distribution. And through my research, I kind of read a lot about how these areas on the northeastern seaboard and the Long Island region are used as pupping grounds and often for mothers rearing their young. And something about fosid seals is that they often, especially mothers, if they exhibit signs of stress, whether physiologically or just exhibiting any types of external stress due to human interaction or like natural disasters, they will abandon their young. So that kind of indicates why we have such high levels of individuals coming into the facility that are emaciated or dehydrated. So going into the discussion, kind of interpreting what this all means, like I just said, a high percent of seal strandings that we did see in these individuals, 52.2% exactly, reflected high rates of dehydration and emaciation, reflecting prior metabolic compromise. Again, most of them were young or yearlings. And gastrolith injection, which I found this interesting. Harp seals, like I said previously, are an Arctic species, and a common stress behavior that they exhibit to regulate their body temperature in an Arctic setting is swallowing, like kind of eating snow or ice to lower that internal temperature if they are exhibiting a high outer body temperature. So we see a lot of harp seals coming in that have ingested sand or gravel if they strand on a Long Island region, and they just automatically think to exhibit that stress behavior. So that occurs for 21.7% of seals that we see coming in. And in terms of transit duration effects, while raw distance did not show a statistical morality relation, transport over 35 miles correlated with a higher rectal temperature of greater than 39.8 degrees Celsius. And in Fahrenheit, that is 103.6 degrees. And think of seals having similar body temperature averages as humans. So think of how you would feel if you had a 103.6 body temp, not great. And hemoconcentration, which means your blood has too little water and is too thick, often due to that dehydration due to transport stress and overheating. So some conclusions and further steps: modernizing wildlife emergency response and protocols for a changing climate. We are seeing more harp seals stranding in this area due to overheating because of higher water temperatures. And most of these are exhibited by, performed by the New York Marine Rescue Center when we are having harp seals coming into house. First of all, equipping rescue vehicles with active cooling systems, ice pack bedding, temperature monitorized crates during transit, which is performed, as you can see, we sometimes even ice them on initial capture in on the beach or in the field, and field resuscitation when needed, possibly implementing field triage protocols to administer subcutaneous electrolyte solutions early. So just physically administering IVs through that thick subcutaneous blubber layer if needed in an emergency situation, and implementing decentralized outposts. So just stabilization stations or kind of administered stops throughout high density areas like the New York City region and congested places on Western Long Island. As I said before, my personal opinion is that we will be seeing more of these seals stranding just due to high temperatures in this area. So I think that could always be helpful for future endeavors. And that is all I have. Special thank yous to my faculty mentors, Dr. Joe McClenachan, and my academic advisor, Caitlin Giglio. Thank you for answering all my questions throughout the last year. And my amazing internship supervisors, Andrea Jalaska and Maxine Montello, and all of these staff biologists at the Rescue Center and amazing volunteers. Thank you.
Would the investigation of sand and gravel cause like be more issues with the animal, or that's just kind of how you measure that stress?
Yeah, I mean, that is a primary reason for, in that case, for needing our care. It does make them sick, just further ingestion issues. And eventually something that we need to treat through medication in our care in our facility.
So I know you mentioned a lot of the issues with juveniles, right?
Yeah.
Do you think that the parents are having the younger seals maybe because of food or something other related to that? As to why there's so many like in Suffolk County as opposed to Nassau County?
That's a great question. Suffolk County waters, I think, are just primarily more productive. And in terms of migration, it's further physically out in the ocean. So I think that's, and they're also less crowded. Like think of like Western Long Island and New York City, those waters are very populated in terms of vessels and just recreational boats. And initially coming off the Arctic kind of Gulf Stream, it's just closer. So that's my personal opinion on why I think we see more strandings there.
Thank you.
Stuck in the house. I don't want to break it.
All right, up next we have Sydney Mancione talking about advancing shark conservation on Long Island through research and education.
Hi everyone, can you hear me? Okay, so my name is Sydney and the title of my internship that I did this summer is Advancing Shark Conservation on Long Island through Research and Education, and I did my internship with the SoFo Shark Research Team. So the SoFo Shark Research and Education Program is a research team that operates out of the South Fork Natural History Museum, which is a 501c3 nonprofit organization located in Bridgehampton, New York. And the mission of the Shark Research Team is to enhance stewardship of Long Island shark community through scientific research, data sharing with marine resource managers, and educating the public about the important ecological roles of sharks. So for some more background about the Shark Research Team, they tagged the first young of the year white shark in the Atlantic Ocean in 2015, which then led to their collaboration with OSearch, which is a global nonprofit organization that works on tagging white sharks. And their work in 2016 and 2017 established the White Shark Nursery in the New York Bight area off the shore of the South Shore of Long Island, making it 1 out of 3 scientifically confirmed white shark nurseries in the entire world, and the first and only in the North Atlantic Ocean. The overall goals of the Shark Research Team is to tag and track sharks around Long Island, collect data on things like their movement, their behaviors, the temperature of the waters that they spend their time in, and how frequently they're seen around our waters. And they also educate the public about the roles of sharks and try to eliminate some people's misconceptions or fears about sharks and their importance right here on Long Island. So now for some background about the importance of sharks. So many sharks can act as apex predators in ecosystems, which means that they prey on weak, sick, injured, mid-level predators in our ecosystems, which basically means that they balance the amount of different species in that food web. They also help promote overall ecosystem health by preying on sick or diseased animals, removing them from the ecosystem. And many sharks are ectotherms, which means they rely on the water temperature surrounding them to regulate their internal body temperature. So that is really important because the research that collects data about the water temperatures and the temperatures that each different species of shark spend their time in is important for providing insights into how climate change may affect them. One of those ways would be causing range shifts and where they're found, because they may need to follow their prey who are moving due to water temperature changes, and also to regulate their own body temperature. So for my internship, I had 2 main components. The first one was data analysis. So I was provided with some data to look at some of the information they've collected over the years about sharks off the shore of Long Island. And the second part was to update an educational exhibit about sharks located at SoFo Museum in Bridgehampton. So first, for the data analysis, I was provided with PSAT data, which stands for Pop-up Satellite Archival Tag. And PSATs record depth, temperature, and light. So they are attached to the shark that's caught, and they record data for 28 days, and then they're set to pop off after that amount of time. And then researchers are able to have that data on the depth, the temperature that those sharks were swimming in. So these 3 species of sharks that I was provided data for were tiger shark, scalloped hammerhead, and then I had 2 tag data sets for common thresher sharks. And the main objective of this part of my internship was to determine any differences in dive profiles between each shark. So that means basically I was looking at if they had different temperature or depth thresholds and then compare them to one another. And in order to analyze my data, I used Microsoft Excel. I calculated things like the mean temperature and depth, the maximum, the minimum, and then I also calculated the daily averages, and I imported that into RStudio for further analysis on there. And then for the educational exhibit portion of my internship, the main goal was to update that exhibit, make information more relevant to Long Island specifically, because as of right now, it's more broad focused on a lot of different species of sharks that can't be found here on Long Island, a lot of information, and we can see pictures on the right side of what it currently looks like. So there's a few different components of this exhibit. There's the wall mural, which has some images of sharks that can be found here, as well as a little bit of information about them. And then all the way on the right top picture, we see the collaboration that was done with OSearch in 2016 and 2017 is on there. And then there's also the bottom picture, which shows the interactive touchscreen portion of the exhibit, which has a bunch of different sections that people can click on and look at information about the shark research program. They can do a virtual tagging experience and see what researchers on the boat do. There's some images. There's a big section about threats to sharks, which has a lot of information about things that might be harming populations worldwide. And then there are some other games and species matching to images on there as well. So my objectives for this upgrade were to add some different content and focus it, like I said, on more things that are related to Long Island. So the first thing I did was eliminated species that cannot be found on Long Island, and I upgraded the information on there to be more current about the species on Long Island. So I added everything about local species, and I think I have about 16 main ones that can be found here that I talked about in there. Another section of the upgrade for the wall mural was to talk about the food web. So right now, the images that are shown on the wall mural are just pictures of sharks, but a goal was to add a food web so that people can learn about specifically here what sharks are eating and then what they're eating, and so on and so forth. And then another objective was to talk more about climate change. There's a broad section about climate change, but obviously as years go on and climate change intensifies, it's increasingly important to talk about. Another thing to add was about the collaboration done starting in 2022 with the Peterson Lab here at Stony Brook, where they deployed acoustic tags on a bunch of different marine organisms, but as far as sharks go, there were duskies, sandbar, sand tiger, and smooth dogfish that they put those tags on. And the goal of that was to determine the pre, during, and post offshore wind farm development, and if that had any impacts on movement of those species. So that was also something that we wanted to add on to there, because the last upgrade of this exhibit was before that started. And then finally added conservation policies. So I talked about fishing regulations, specifically in New York State waters, how certain types of hooks, circle hooks, must be used instead of J hooks to prevent sharks from being gut hooked, and as well as the species that are prohibited to catch in New York State waters, the ones that are endangered. And as speaking of endangered, I also updated the information about each shark. So for each of the species that I included, I followed this format. I had their scientific name, their IUCN Red List status. So that's something that I had to make sure I went in and looked at again because lots of those had changed since the last update. I also included information about each shark's size, their lifespan, their reproductive habits, their diet, their habitat, behavior, and I also included a fun fact. So this is the example of what I created to be used for the smooth hammerhead shark. And then for my data analysis portion of my internship, like I said, I had 4 tag data sets that I looked at. And this is what I made in our studio. I did first stacked line graphs that show the relationship between the temperature and the depth that the sharks were in. So on the left side, I have the 2 thresher sharks. One of them, named Leroy, was tagged in 2020. Enid was tagged in 2019. And then I have the tiger shark, which was tagged in 2022, and the scalloped hammerhead, which was tagged in 2024. So this was a nice visual for me to see the relationship between temperature and depth between each of the shark species. And then I created these box plots that show the habitat temperature of tagged sharks using the average daily temperature, as well as the vertical distribution of all of the tagged sharks. And we can see that Enid, which was one of the thresher sharks, had the deepest depth and the coldest water temperature out of all of the 4 sharks. So that's what that little star indicates, that that one is statistically significantly different when I performed an ANOVA test, also using RStudio. And lastly, I created this scatter plot on RStudio using the temperature and the depth, and I color coded the depth by the temperature. So you can see that once again, that Enid was in the coldest, deepest water. And then my overall takeaways from the data analysis portion are that the common thresher sharks both had the deepest swimming depths, even though only Enid had a statistical significance in the difference between the depth and the temperature, which makes sense for thresher sharks to be found in the deepest and coldest water because, as I stated previously, most sharks are ectothermic, but common thresher sharks actually are regionally endothermic, which means they are able to regulate their internal body temperature, which means they should be able to tolerate a wider range of water temperatures. And as you get deeper in the water column, the water is going to be colder. So that's also important to consider that sharks that are endothermic might have different impacts by water temperature than most ectothermic sharks. And then the scalloped hammerhead was in the warmest water temperature and the shallowest depth. It spent most of its time like right near the surface of the water, which is also important to consider. So future research should combine these findings with geographical data because it is a lot easier to understand where they might have been going, why those water temperatures were higher or lower, and create a more complete picture of their dive profile, as well as further analysis of thresher shark Enid's data, because on my scatter plot, you could see that the color coded seemed to be flipped, which could indicate that there was an error in calibration of the tag, or while it was being uploaded before it was sent over to me, it may have switched some of the depths and the temperatures where there appeared to be an atypical pattern where as you got deeper, the water temperature was warmer. So that should definitely be looked into further again from the raw data. And then it's going to be really important to compare the dive profiles with more individuals because I only looked at 4 sharks, and to establish any sort of more significant pattern, it would be essential to look at more individuals. And the overall importance to marine conservation of this project, the ocean has already absorbed about 90% of the excess heat from our warming atmosphere, and as it continues to warm, sharks will remain in their northern habitat later into the year. Just a 1 to 2 degrees Celsius increase has already seen up to a month in delay of migration patterns. So that means that we might have sharks here later than we would expect. And that has implications for fisheries management, which is important to consider when establishing different regulations and catch quotas for sharks' prey, And overall, the educational portion is really important for promoting public awareness and using that as a tool for conservation and eliminating fears that people may hold about sharks. And I want to say thank you to everybody that helped me during this internship, especially Frank Clavetto, who's the SOFO Executive Director, Dr. Toby Curtis, who's the SOFO Sharks lead science collaborator for all the data, Lindsay Graff, who helped me with all the RStudio stuff and the data analysis, and Captain Greg Metzger, who let me go on the boat this summer to see what they do when they tag a shark on the boat. And thank you for listening. Does anybody have any questions?
Thank you so much.
Up next, we have, hang on, there we go, Jade Blano talking about the Peconic Estuary Partnership, expanding the mosquito sampling citizen science program. That's for you.
Hi, everyone. My name is Jade Blanow, and I'm here today to talk about my capstone project, which was devoted to figuring out if we could expand a citizen science program that went on in East Hampton. It was a mosquito sampling program, and my project really focused on how to make deliverables that best served to expand that program, because I think that the success of it really was not well put on blast. We want to make sure that people are aware of this success and the potential for it to move forward. So this is my overview. I'm really going to focus on the success of the program, how it was successful, why it was successful, and what our next steps are. So this work was done with the Peconic Estuary National Estuary Program. I have to admit that I do work there. I've worked there for a couple of years. And during that time, I also was collecting a handful of graduate classes throughout SoMAS and beyond. And I'm really thankful to Kaitlin for helping me so much to focus my efforts into this MCP capstone. I think that this was a great venue for me to bring all of this together. And this project specifically is something that could have really only been done at the MCP program, so thank you. The Peconic Estuary Partnership is one of the 28 national estuaries of significance. It is a non-regulatory body, and it's really focused on community-driven relationships. Can we get the community together in a way to help empower them to make data-driven watershed management decisions? So the Peconic Estuary Partnership is driven by these 4 general goals, and these goals all came together and are really seen in this mosquito sampling program. I have a little arrow right there for Accabonac Harbor in the town of East Hampton, where I'm focusing, and we'll jump right in. So in order to understand this work generally, you really need to first get a handle on why salt marshes are so important, and I'm sure that this room is very aware, but overall, the ability for salt marshes to assist coastal communities in flood mitigation, in carbon sequestration, for providing food, for providing all kinds of climate regulation needs from their root zones, holding carbon, and the need for that, as we also use them for ecological, for cultural and economic reasons as well. So salt marshes, although very important, unfortunately have a history on Long Island of not being treated very well. We have many degraded marsh systems, and when marsh systems face these degradation, it really lands to standing pools of water. We get a phenomenon called subsidence, and subsidence is when the marsh platform itself is slowly sinking down. A large part of my job outside of this capstone is really focused on the research and background around salt marsh subsidence, how and why it's being caused on Long Island specifically, but also what are we doing to address these issues? So that's a separate presentation, but if you're interested in that, please give me a call. These standing pools of water over time, though, are fantastic areas for mosquitoes to breed. So who's in charge of mosquitoes breeding? Mosquitoes are a nuisance species, so they can carry all kinds of diseases that are a public health concern. So out here, we have Suffolk County Vector Control. This division is specifically given the responsibility of finding a way to move this forward. So they protect public health across the entirety of Suffolk County. They use this integrated marsh management philosophy, which is both using chemical treatment where necessary during the mosquito breeding seasons, but also recognizing that the core issue is at the root of salt marsh hydrology. And they recognize and really lobby for funding to go towards marsh restoration to hit this issue right in the marsh, right where it's needed. So they applied a granular larvicide as well as spraying adult mosquitoes if absolutely necessary. So this is done via helicopter, something to make sure that we recognize as we talk about this. Only in late spring through summer. So if you can imagine a marsh like this, the Suffolk County Vector Control has limited staff capacity to really understand where mosquitoes are breeding in individual pools on marshes. So they have their own capacity limitations. So they really rely on these large spray blocks where they've known historically mosquitoes have been breeding. When they take helicopters out there and spray with larvicide, they need to make sure that that effort is worth it. And so they're spraying over these large areas. So now on to the program. So the pilot program that was created back in 2017 is a citizen science campaign that was majorly coordinated by Nicole Marr at the Nature Conservancy, someone who has been extremely helpful in understanding all of this process. And she was really the effort behind this, and we have her to thank for sure. So the Nature Conservancy partnered with Suffolk County Vector Control directly, as well as with support from PEP, East Hampton Town, and the trustees, to put together a volunteer-assisted mapping effort. So volunteers were assembled and coordinated to go onto the marsh every Monday morning for these weeks of the spring and summer. They went out there and sampled and were able to give that information directly to Suffolk County Vector Control to have their team only treat hotspots with this larvicide. If we could do that, then they were able to reduce pesticide exposure, reduce flight time, and increase transparency between the public and how Suffolk County Vector Control was making these decisions in their own community. So how do you do that? That's the ideal scenario. Well, it was mass coordination of this Monday morning group. They collected dip samples at key locations and on specific tides. This was all put together by Nicole Marr at the Nature Conservancy. She also helped to co-develop an ArcGIS survey in across Accomack Harbor, where it gave volunteers the information needed to say, these are where hotspots are known. You're gonna, each of these Monday mornings, you're gonna walk through, you're gonna take this dip sample cup, just like shown here. You're gonna test, you're gonna take a picture of what's in your cup. That'll help us identify abundance of mosquito larvae and what stage of their life they're in. That ArcGIS survey was then directly sent to Suffolk County Vector Control that morning, which I'm sure you guys, I hope, use ArcGIS. It's an amazing tool, especially the Survey 123. So using this, they were able to identify the true active breeding spots, not legacy knowledge. So with that, they reduced the number of acres that Suffolk County Vector Control treated over time. They lowered the operational costs of this entire division. They limited chemical exposure to humans and wildlife. And their reporting really shows that their consistency of results since starting this in 2017 shows that the program itself is reliable, scalable, and is operationally useful for Suffolk County Vector Control. It's really a scenario where citizen science data is not kept on a shelf. The citizen science data is used directly, immediately with results. So me learning about this program, I was so excited to have my MCP really dedicated to showing the results and success of this program, as well as how can I support the replication of this in other areas. So I set out on all of these interviews. I interviewed the Nature Conservancy, the town of East Hampton trustees. I interviewed Vector Control, sat down with them, and they provided me even with this map of 17 locations where they currently are spraying this aerial larvicide. And this is only in the Mccenachan estuary for the record. So my capstone deliverables that I'm going to talk today with some limited time is really going to be about the toolkit and deliverables that I have developed in order to help a future site coordinator to take on this role and get the citizens together and be able to connect with Vector Control to have this happen in a new site. So first I made a toolkit option of setting up your program. It's all about how to connect with vector control, how you identify the sampling sites needed on a single marsh, what time of year you go, how many times you need to go. And it also talks about how you set up the survey app that was initially developed by the Nature Conservancy, how you can set that up to be connected to vector control. It's giving you the contacts necessary for any site coordinator to be able to do this. Next, I made a general fact sheet for that person to hopefully work on. That person can then go out and try to recruit volunteers using the information in this fact sheet. It's already set up for them. Then I made a volunteer training manual. This is based off of and has links to videos of people doing the dip sampling. It talks about what were the issues, what is the type of field technique you need for this data to be considered by vector control. They want to make sure that their volunteers are trained and are taking data in the same way that they would be, as well as identifying the larval stage, using survey 123 in case that's the hurdle, and all types of what is the gear you need, what is the personal protective equipment you need when you're working with mosquitoes. So that is the training manual, and at the end I kind of kicked in another little treat for this person, which is a full grant proposal template. I think that there's the possibility of this being funded by an agency because there is the need for someone to coordinate this effort. So there is a template for a grant proposal in there. So the next part of my capstone was really looking at the viability and site selection, looking at those 17 places across the estuary. Where can this program be most successful? So I did some ARC Pro and I recognized where are those spray areas, how large are those blocks, where is publicly accessible lands, as well as where is the pilot site boundary. I did some clipping and cleaning up of all of this data, and I ended up finding 5 viable places that I really thought program expansion would work. They all have public access for those volunteers to be able to get into the marsh, and they have existing spray activity that could be reduced. So overall, the ending of my report kind of talks about that. If I were to choose a #1 site, it would be a zoom in right here in Southampton town, right on the border of Southampton and Riverhead in this Flanders area, which I know we have some Flanders locals, so shout out. So in Flanders, why did I choose this site? Overall, there's an existing aerial treatment that happens every single year in the summer. I know that there is public access, publicly accessible land for these volunteers to be able to get onto the property any Monday that they need without needing additional permits. It is a known New York State environmental justice area, which shows that this type of work would have great benefits to the area, as well as they have a really strong local capacity. At Peconic Estuary Partnership, our Citizens Advisory Council that gathers citizens, they have a very strong civic association, and I think that they would be very capable and very excited to take on this type of work. So that made altogether why I would love for them to really take this on first. So overall, the toolkit that I provided and that I made over this capstone, I really wanted to just set somebody up for an amazing gig. I think that anybody in this area has all of the tools needed for them to be able to push this program and replicate it. There is info on site ID, there's funding needs, there's ready to use foundational information for future implementation. And I just want to really recognize that all of this work and all of this groundwork was only able to be done because of the Peconic Estuary Partnership's very specific outlook. The way that they are positioned in the community is to leverage relationships in order for them to connect state, local governments, as well as nonprofits and civic associations and the community itself. So it was only through that a project like this could come together where we could highlight this amazing program. So that's it. I just want to say thank you so much. Kaitlin, thank you again for all of your help. Thank you to my colleagues at PEP. They all helped me, and I'm thankful to David Taylor for his assistance throughout this as my advisor. And especially to the Nature Conservancy, Nicole Marr, for starting this project. I'm glad that we can give it some good outreach and let people know that this is possible and all the places that this could be done in the future. As well as the town and Suffolk County Vector Control for being so transparent with all of their data and so supportive of this moving forward, which is really what I want from this. Thank you so much. Anyone have any questions? Mosquitoes.
All right, everyone, thank you so much for making your way back here in a timely fashion, even though we had lunch late. I want to start off our afternoon session by introducing Kira Healy, who is going to talk about living shoreline projects, inventory and policy analysis. Go ahead.
Thank you, Kaitlin. I wish I could have made it in person. Unfortunately, I broke my toe, but I did want to congratulate everybody who is presenting today and finishing their program. And yeah, so my name is Kira Healy, and today I'm going to be sharing with you all my internship with the DEC, where I developed a database interactive map and webpage to help track living shoreline projects in the Marine District. So New York's coastal communities are facing increasing pressures from sea level rise, erosion, and more frequent and severe storm events. And as these conditions intensify, the need for effective shoreline stabilization strategies continue to grow. And traditionally, many shorelines in New York have been armored with things like bulkheads. And while these structures can provide short-term protection, they oftentimes lead to habitat loss, increased erosion on adjacent shorelines and sometimes behind the bulkhead. And they also sever the connection between land and water environments. Where living shorelines, on the other hand, use natural materials like native plants to stabilize shorelines, and they work with natural processes, making them a more sustainable option. And despite their benefits, living shorelines are still relatively new in New York. And until recently, the state lacked a centralized way to track where these projects were being implemented. So this gap created a need for a standardized system to organize and communicate this information, which is what led to the development of my project. So living shorelines, as I mentioned, have been a growing focus in New York over the past several years. And in 2023, an amendment to the environmental conservation law required the department to authorize and encourage the use of nature-based solutions as the preferred alternative for stabilizing tidal shorelines where feasible. And this new policy reinforced the need to track living shoreline projects across the Marine District, which is what led to the creation of our database. Sorry, I think it's lagging. Okay, there we go. Oops. Okay. So for my project, I worked with the DEC, specifically the Division of Marine Resources in the Bureau of Marine Habitat. And my project had 3 key objectives. The first was to develop a standardized internal database of living shoreline projects permitted in New York's Marine District. Second was to create a public-facing interactive map to display the completed living shoreline projects and allow users to explore project locations, techniques, and goals. And lastly, to develop a living shorelines webpage on the DEC's website to host the map and provide background information, guidance, and educational material for the public. So together, these objectives were designed to improve internal tracking, support public outreach, and strengthen New York's ability to advance nature-based shoreline management in the state. Sorry, I don't know what's happening. Okay, there we go. So first, I created an internal database of completed, in progress, and proposed living shorelines in the Marine District. And to collect this data, I coordinated with regional tidal wetland staff in our Long Island, New York City, and Hudson Valley offices. And for each project, I compiled permit data and associated documents, project plans, design details, monitoring reports, site photographs, pretty much any relevant data I could find on these projects, I added to the database. And this database provides a standardized way to collect, organize, and update information on living shoreline projects across regions, which helps support more consistent implementation and permitting. And next, I used that data to I used the data I collected to develop a public-facing interactive map. And this made information more accessible and easier to view. And I used ArcGIS Online and Experience Builder to create the map. So this is kind of an overview of what the map looks like when you first open it. As you zoom in, you can get a better sense of the projects as you press on a specific site, and also the labels for the sites do appear as you get closer if you're interested in seeing what each project is called. And yeah, a pop-up window will show you a photo of the site as well as additional information, description of the project, the techniques that were used, the year it was installed, etc. And a couple sites even have a link to a photo time lapse. So something like Chronolog, for example, is set up at this particular site. So that's a really great tool to be able to see the progression of the shoreline pre and post living shoreline construction. We also added a toggle feature for living shoreline techniques. And this tool is great if you're interested in, seeing where certain techniques are often used in the Marine District, or if you're just curious to learn more about the different techniques. And finally, a Living Shorelines webpage was created to host the map and provide supporting educational content. And this webpage has a couple different sections, including some background information on living shorelines. There's a section that compares traditional hardened shorelines versus living shorelines. There's a section for living shoreline benefits. Of course, there's the interactive mapper that is linked on here. There's also a section for a living shoreline case study, which is the Shorefront Park living shoreline in Patchogue, which is one of our largest and I think most successful projects to date. And if you scroll all the way to the bottom, there are some additional resources for tidal wetland permitting and some living shoreline guidance. So quickly looking at some of the results, our internal database that was developed has 28 standardized fields, while the public-facing mapper is a simplified version of that, which consists of 13 different fields. And looking at projects that were identified, we have currently 22 completed projects in the Marine District, and we have 8 projects that are in progress currently. So that means they have been permitted and they're either in construction or they're soon to be in construction. And now looking at the number of completed projects over time, we do see an increase in implementation in more recent years. And although it is still a little bit too early to see the full impact of the 2023 Living Shorelines policy, this trend does suggest growing momentum in implementation of living shoreline. So as I mentioned, we have 22 overall completed projects, and most of those are located on Long Island. And of those Long Island projects, most are located either in the Peconics or on the South Shore. We don't have very many projects on the North Shore currently, and that just is mainly due to the environmental conditions on the North Shore being rocky beaches and steep bluffs. it's not as conducive to these type of projects. And looking at project design, most projects in the Marine District tend to have a hybrid design that combine marsh plantings with sand fill and some sort of structural element like rock sill. So overall, tracking this data helps us determine what techniques are being used, which ones are working, and where we can potentially implement more projects in the future. So looking at the broader significance of this project, it does support marine conservation and policy by improving New York's ability to track and communicate living shoreline projects, supporting implementation of state legislation and policy transparency. This project improves internal permitting efficiency by consolidating living shoreline information into one standardized system, and enhances public outreach and awareness by making data more accessible. Regionally, this project aligns New York with other established living shoreline programs in other states like Delaware and North Carolina. And lastly, the tools developed in this project provide a foundation for future monitoring and evaluation that directly supports New York's new living shoreline legislation. And quickly, I wanted to just touch on a couple of next steps. So we will be continuing to update the database and map as we receive more data and as more projects are permitted. We are also planning to develop a living shorelines monitoring plan template for permit applicants to help standardize monitoring data collection. And we'll also be checking webpage analytics periodically to see how often the webpage and the map are being utilized. So I wanted to just thank you all for your time. Special thanks to my mentors, Dr. Chen from SoMAS and Alexa Fournier from the DEC. And as well as thank you to my other DEC colleagues that have helped me with this project along the way. And I would be happy to answer any questions.
Got them all on their pizza comas right now.
Yeah.
Thank you.
I do have my email up on the screen. I don't know if the screen's still showing, but if anyone thinks of anything later and wants to email me, I'm happy to chat about living shorelines, anything living shorelines related.
Oh, we have one question. Go ahead, Eliza.
When you're talking about permitting, are you talking about people wanting to establish their own living shorelines or build structures near these living shorelines?
So when we're talking about permitting, we're talking about tidal wetland permitting of implementing a living shoreline on either a homeowner's property or at a municipality, a park, etc.
Thanks so much, Kira.
Yep, thank you.
Up next, we have Julia Samuelson, who is talking about mapping the seafloor with NOAA.
Great, thank you, Kaitlin, so much for the introduction. I'm Julia Samuelson, and this summer for my internship, I mapped the seafloor with NOAA. My official title is a hydrographic survey technician.
You're good.
Okay. And this summer I spent my time aboard the Nancy Foster 186 oceanographic research vessel. My responsibilities included operation and monitoring of hydrographic instruments, perform data acquisition and processing through specialized software such as Keras and HYPACK. I maintained and collaborated survey equipment along with identifying system issues and handled mooring lines to assist with small boat transfers and launches. This project was conducted by NOAA's Office of Coast Survey in collaboration with academic partners to map several large priority areas. So why is mapping the seafloor important? Okay, sorry, that's out of order. So mowing the lawn, this is our 3 somewhat polygons of the southeast shore of South Carolina that was requested for hydrographic surveying. One of them being Blake Plateau, a deep water coral, which is out past the shelf. The primary objective of this seafloor mapping project was to collect multi-beam bathymetry, acoustic backscatter, and water column data, which will be used to update NOAA's nautical charting products. The project also addressed NOAA's requirements to provide continuous multi-beam coverage within the U.S. exclusive economic zone. So mowing the lawn describes the tedious nature of hydrographic surveying, collecting data along parallel transect lines for several hours in each direction to achieve complete seafloor coverage. So why is mapping the seafloor important? NOAA's ocean exploration visually discovered Blake Plateau, the world's largest known deep-sea coral. This coral is essential for habitat for diverse marine life, supports global fisheries, and contributes to the thriving ecosystems and overall ocean health. Habitat mapping of the seafloor identifies and protects vulnerable habitats and predicts climate changes through evaluating how ocean conditions evolve under changing environmental pressures. So this picture was taken in 2019 during a NOAA ocean exploration, and it was titled Windows to the Deep Exploration with an ROV camera. So that's what Blake Plateau looks like. So our survey methods, the multi-beam bathymetry is a sonar device. It emits multiple beams of sound waves towards the seafloor. So these beams spread out in a fan shape from the transmitter array mounted on the ship's hull. When the sound waves hit the seafloor, they are reflected back to the transducer or the transmitter receiver. The system calculates the depth by measuring the time delay between the emission and the reception of the sound waves. Acoustic backscatter is the measure of sound reflected by the seafloor and received by the sonar. Return signals reveal the composition and texture of the seabed. So there's typically hard or soft returns. A hard return is a strong backscatter signal, which can be rocks or shipwrecks or coral that cause strong reflection of sound waves, compared to a soft return, which is typically a weaker return and represents a soft bottom such as mud or sand. So this is kind of what my days were looking like on the Nancy Foster. The dry lab is equipped with advanced technology and modern screens. Displays include raw acoustic backscatter. So this is what I'm talking about with the soft and hard returns. This dark is a hard return indicative of some coral. We also recorded depth profiles, and we used HiPAP, which is a data acquisition system, and was also used up with the steering, and it was used for orientation control during surveys. And the transducer is on, sending and receiving the acoustic signal, confirming the system is active and synchronized, which is essential for accurate data collection. If these 3 buttons weren't on, I wouldn't have a job anymore, so I had to take very good care of that. So for data collection, there's 2 different types of multi-beam echo sounder systems. There's an EM2040 and an EM712. So we went to 2 different survey sites, one 45 miles off of South Carolina. So we used the EM2040. That's a shallow water multi-beam echo sounder system. And it's operational in 0.5 meter to 600 meters of depth. It emits short pulses at higher frequencies, and it's limited penetration but high resolution data. And then when we were out at the Blake Plateau, which was 180 miles off coast, we used the EM712. That measures 400 meters to 1,500 meters of operational depth. Longer pulse lengths and lower frequency. It gave greater range coverage and deeper penetration for cleaner bathymetric results. And we also used of CTD, we did underway and static, and that measures conductivity, temperature, and depth casts. Daily expectations included scheduled static CTD casts using the Seabird 19. Deployment of underway CTDs were as needed for sound speed profiling. So this is what the outside of the boat looked like, and we have our underway CTDs, which was used while the boat was moving, and this is our static CTD, which was while the boat stopped. So that was a whole entire boat operation. That's my boss then conducting the static CTD. Captured water column profiles are essential for sound speed corrections. CTD casts are also needed for echo beam sounders because they provide the sound velocity profile required to convert raw travel time data into accurate depth measurements. So basically what that means is depth changes with pressure. And with all the data that we have, we need to make sure we do a sound velocity profile cast and get the measurements of the depth and the temperature to accurately understand the pressure to get the depth. So these are some of our maps and our results. So this is what Lake Plateau looks like with the hydrographic survey map. And these darker areas represent the coral. We kind of knew coral was there because they've gone out to that spot before. But that's a hard return, and this was a lot of what the map looked like altogether. So we weren't getting physical camera looks, but we were getting depth profiles. So how does this relate to the MCP program? Reforming cold water coral species serve as autogenic ecosystem engineers, sustainably modifying the surrounding environment and creating habitat niches for many other species. Preserving this coral is important because, one, reefs provide hard substrate and shelter for a wide range of species from small invertebrates to predatory fish. And cold water corals are slow-growing, long-lived, and fragile. These qualities make them highly sensitive to physical damage from anthropogenic threats. And this work also relates to ocean conservation, because high-resolution spatial patterns and biophysical characteristics of the seafloor advance the understanding of ecosystem dynamics and habitat distribution. So this project internship was the integration of science, technology, and policy to address marine conservation challenges. So my reflection. My experience was great because I had the opportunity to be employed by NOAA, but had the best of both worlds, learning as a professional and a student with other involved university academics through CCOM and OCEI. I give my thanks to the Nancy Foster crew, Dr. McClenachan, Katie Watkins, the SoMAS professors and staff, my amazing MCP friends, and my great bosses, Ben and Sam. And these are my references. Thank you. Time for a couple questions. Yes.
So you mentioned that there were some anthropogenic threats for cold water corals. What would some of those be, just because they're so deep?
Yeah.
The water column?
Yeah. I would say just trawling in general or anything messing with the seafloor. It was around 600 meters deep. And there are a lot of good species down there. They're still trying to discover it, but I would say besides anthropogenic threats, it would be more of global temperatures and ocean water temperatures rising. That's more maybe a bigger threat. Mm-hmm.
How often did you go out on the boat?
I was on the boat for almost a month, 24/7. Yeah, it was a lifestyle. For sure. Food was good though, so. Anything else? Yes.
When you are doing those like bathymetric, the backscatter stuff, can schools of fish or other things like that impact your backscatter?
Yeah, I'll show you really, really quick. You can, it's kind of hard to see, but this is a snapshot of our live sonar water column. Typically in here, there would be these little imprints that kind of look like a fingernail, and when they're bent, that's when you could see like schools of fish. So when we were getting closer inland, we saw a lot of that, and it was going crazy.
Thank you.
Thank you.
Thank you so much.
Thank you.
Great, thank you.
And I'm not gonna mess the title up. I am probably gonna mess the title up. Hang on. Whoops. Mess it up. All right, so up next is Emma Stefanik talking about fact versus fiction, examining trends in media perception of sharks in New York.
Hello, everyone. My name is Emma, and my capstone is titled Fact versus Fiction, Examining Trends in Media Perception of Sharks in Long Island. My mentors were Oliver Shipley and PhD student Ashley Nickel. And a little bit about why I wanted to do this was I've worked with sharks previously, so I really enjoy them, and I think they're a really important species. But I wanted to hone in into Long Island because I am not originally from New York, so I wanted to focus on the area specifically. So for some starters, human interactions with wildlife are a defining experience of human existence, and in many places, an increasing challenge as the human population increases. Impacts from these interactions can be direct or indirect, and injury can even result in death. Human-wildlife conflict is currently a widespread issue for conservation science, as results to conflict are often disproportionate to the level of damage. Certain species even gain perceptions that are innately evil or harmful, where mitigation is then rooted in fear. New York is currently facing an increase in human-shark interactions, with 15 confirmed cases since 2018. These interactions lead to an increase in media coverage attempting to assign reason to these incidents. Sharks are often covered in a negative manner containing misleading or inflammatory information. Previous studies have even shown an increase in media coverage for prolonged periods after fatal interactions. Others have also found that shark attack and attack are present in a third of headlines. The term attack is actually even used when no physical harm has been inflicted. The constant use of the term presents a false impression of sharks and the incident itself. The use of negative language can create a perception that lowers the public's threshold for accepting sharks and conservation policies. Some studies even suggest that the increase of interactions may not be due entirely to the change in sharks' behavior, but rather an increase in people. Research by Ritter and Amen and Lagabrell both discuss how there is strong correlation between the amount of beachgoers and previous interactions. Oops. With news outlets making negative and false claims, it becomes important to analyze what is being said about sharks. And in this study, I examined the language trends related to articles covering sharks' activity on Long Island, as well as the potential overlap between shark occupancy and periods of high beach attendance. These findings should help inform the involving public exposure to sensationalizations in shark-based media while providing insight into the role beach attendance has in explaining interaction occurrence. So for collecting the news articles, I conducted a Google search using the terms Long Island Shark News from 2020 through 2025. Any video clips, Facebook posts, or duplicate articles were removed. The title, date of publication, news outlet, broadcast level, and a summary were all collected. Articles were then categorized into a general or interaction-based group. Negative words collected were attack, shark-infested waters, bloodthirsty, man-eater, monster beast, terrifying, horrific, Larkenstock, and Jaws, as suggested by David Schiffman and the Wildlife Conservation Society, due to their association with negative framing that perpetuates fear and misunderstandings. Comparisons between article over month, year, and broadcast level were done, as well as frequency calculations for word usage. For beach attendance, daily state park attendance was obtained through the New York Open Portal Freedom of Information and New York Open Portal for Jones Beach, Robert Moses, Montauk Downs, and Montauk Point. Rockaway data was only available from the last week of May to the second week of September. Mean and standard deviation were calculated for each year across locations. For shark detections, daily passive acoustic telemetry detections from 2020 through 2025 were collected for sandbar, sand tiger, and dusky sharks. These species were filtered for false detections by short interval criteria, and were selected because they are common coastal species and prohibited from commercial and recreational fishing on Long Island, as well as being attributed for human-shark interactions. Human-shark interaction data, including the date, location, species, confirmation status, and interaction type, was provided by Chris Scott at the DEC. All data was then processed within our studio. This figure here shows the placement of the receivers that were used. Each circle represents a unique receiver, and the star represents the location where attendance data was pulled from. Attendance and detection data were then summarized into regions, as shown by the varying color on the side. I combined the Montauk Downs and Montauk Point region into one region as the Hamptons, but all regions were left the same as the attendance data. Data was then plotted and aligned for daily timescale for comparison in each region. So for my results with the news articles, there were 277 collected, of which 203 were classified as general and 74 as interaction-based. Figure 2 shows 2022 having the most general articles, with 49 published, and while 2023 only had 15. 2022 and 2023 had the most interaction-based articles with 32 published each year. 2021 only had 1, 2022 and 2024 had none. Now, looking at figure 3, 168 articles were published at a local scale, followed by 90 published at a national level. There were more interaction-based articles published at a national level overall compared to a local scale. Figure 4 shows July having the most publications with an average of 21.5 articles published each year. Figure 5 shows the frequency of words within an article, with attack having the highest frequency, appearing in 60% of articles published, while bloodthirsty only appeared in 0.36%. Other words were present intermediately throughout articles. In figure 6, you can see attack had the most usage, with 360 times in general articles and 472 times in interaction-based articles, followed by jaws used 47 times in general articles. General articles had more diversity of words compared to interaction-based articles, and the frequency of negative words actually increased, started in 2022 and then continued throughout the data set. And you can see this with the more colors visible in the more recent years. Overall, 957 negative words were present in articles published from 2020 through 2025, with 485 used in interaction-based articles and 472 in general articles. For the beach attendance, all regions had peak attendance from May through August. July had the highest attendance rate 75% of the time, and if it wasn't the highest month, it was then the second highest month that year. Jones Beach had the highest attendance overall, with an average of over 8 million people and standard deviation of 677,000, followed by Robert Moses with an average of over 4 million and standard deviation of 670,000. 2025 had the lowest attendance in 3 out of the 4 regions. And now, with considering all 3 data sets I had, dates with the higher attendance and relatively low shark detections is when interactions generally occurred. Specifically looking at Robert Moses in the brown down here, there was a total of 8 interactions, which is represented by the black vertical lines. And attendance varied between 15,000 and 43,000 people, and shark detections were below 12 individuals. This trend was apparent across all regions, even if attendance was not exactly at its highest peak. Out of the 14 interactions, 50% occurred in July. 2022 had the most interactions, with 8 total that summer. July 13th, 2022 had 2 interactions that day, both at Robert Moses, and July 4th, 2023 had 2 interactions, 1 at Robert Moses and 1 in the Hamptons. All interactions were non-fatal and confirmed as a sand tiger or unidentified requiem species, except for the Rockaway interaction, which was a subjuvenile wet shark based off of the bite data. So overall, attack, jaws, and monster and beast were the most frequently used words, which imply sharks are dangerous and should be feared. All negative words were used at least once throughout all articles collected. The use of these words could be lowering the public's perception and support for shark conservation policies based on previous studies. Publications, attendance, and interactions all peaked in July, which aligns with when people are wanting to go to the beach, as it is midsummer as a holiday and is a popular vacation month. Robert Moses had the most interactions and was the second most popular beach based off of the average attendance rates. A few limitations to this study include not including paywall articles due to the lack of availability. Also, attendance data is not quite exact and doesn't cover each individual beach throughout Long Island. There's also a possibility of missing shark detections, as not every individual is tagged and the range that the receivers have. Further research should consider Long Island's perception of sharks and their conservation with negative framing present. More research on variables contributing to human-shark interaction are needed for proper mitigation and to improve explanations given in news media. Overall, Long Island needs better news coverage discussing more diverse topics involving sharks rather than focusing on the negative. These depictions lead to issues for shark conservation, as the public's willingness to support policies can become limited. Media is a powerful tool that should be used to educate the public with information backed by scientific support. Thank you.
Any questions? So I'd be kind of a stretch, but just out of curiosity, do you personally have any idea why Robert Moses was like the most kind of populated area of like that shark and human interaction? Like level that you got? Sorry, I've heard that well. But...
I'm not entirely sure with just looking at like the attendance and the shark detections. It could be because just Robert Moses, the region that we had, might have been the largest like span of area that was included. Yeah. Like if we divided the range of the regions into smaller regions, it would probably be less and more focused on individual areas rather than the 8 all being there.
Yeah.
Cool. Did you find any articles at all that included none of the terms that categorized as negative?
Very minimal. There were very minimal that had like a positive framing, but the majority had at least one present in all the articles.
So when you see these articles posted on comments in the public, they're generally more older. What do you think the motivation is for consistently posting them every summer?
Not entirely sure. I would assume like with a positive perspective, it would be to inform the public that yes, they are there and to be aware of your surroundings. But with kind of the negative framing surrounding them, it almost makes me feel like they want people to want to get rid of them because they're invading their vacation time per se.
Thanks, Emma. All right, up next is Victoria Panuccio, assessing white shark population dynamics in, is it Mossel Bay? Yes. Mossel Bay, South Africa. Go. All right, hi everyone. My name is Victoria Panuccio. My faculty mentor is Dr. Oliver Shipley. My internship supervisor is Dr. Enrico Denari, and my internship head field specialists were Lacey Williams and Zarica Morales. And I will be assessing white shark population dynamics in Mossel Bay, South Africa. In the month of June, I traveled all the way to South Africa to see these white sharks in a place called Mossel Bay. Mossel Bay got its name from early sailors that traveled to the area and found a huge abundance of mussels. So in Afrikaans, mussel means mussels. It's about 5 hours away from Cape Town, which is a very known spot in South Africa, on the Western Cape on the Indian Ocean side. Mossel Bay is very, very famous for its breaching white sharks. Back in 1996, this was first observed by Chris Fallows, which is a photographer who took this picture in 2001. they observed that they were feeding on these Cape fur seals. These are two more recent pictures that were taken by White Shark Africa, which is a cage dive operation in Mossel Bay. And these were taken right off Seal Island. So Seal Island is where all those seals hang out. Those big white sharks were over there, and it's about 8 kilometers off of Mossel Bay. And then this area also turned into a survey site for my internship. So I did my internship with Oceans Research Institute, which was founded by Enrico Gennari himself in 2007. They started the white shark research and internships in 2008. However, they have data that dates all the way back to 2001 and 1995, just from other organizations around the area and from cage diving operations. In 2009, they expanded to marine mammals. And then in 2014, they even expanded to terrestrial research. And then since then, they bring in a lot of PhD students and master's students that bring a lot of independent projects that then interns will assist on. These are some of those projects. So ethical fish biodiversity assessment, we would go fishing for the benthic sharks and the endemic fish species. That's me holding a pajama cut shark, and then we caught this saunter. We would take very standard measurements and collect that data. This was usually done after the project that I'll talk about next. Intertidal biodiversity survey, that's where we would go out and set up a transect from the beach to the ocean and have about 8 to 10 quadrants where we would count the species in that quadrant and identify what they are. There was also a marine mammal land survey where we would look through a theodolite every 10 to 30 minutes looking for dolphins and whales. And then one of the independent projects that one of the master students there is working on is the egg case analysis, where we would set up a transect from point A to B on the beach, collect shark cases and ray cases, go back to the campus and identify them and see where they were hatched. And then other shifts that we participated on were the humpback dolphin population and bioacoustics, drone, ROV, diving, and Identifit. But I was there for a very specific reason, which was the white shark populations dynamics project. This is where we would track the presence, demographics, and behavior of white sharks using identification, tagging, and boat-based surveys. These are 2 photos that I captured of the white sharks off the boat. We did not, as interns, participate in tagging because Enrico was not there and he has to be present for that, but we did do the identification and the boat surveys. And that consists of 6 very standard methods. This was obviously the best one was chumming. It was very, very dirty. That's me with the chum bucket. We were permitted to use 2 salmon blocks to put in the bucket of water and then slosh it up, scoop it, and throw it into the water. It got very, very messy. The other one was GoPro. That's where we would have a long metal pole with a float at the end, a GoPro at the other end, and stick it into the water. We used this data to collect the sex of the shark. We had spotter. This is where the person would go up on the crow's nest of the vessel, look around for the sharks, tell everybody on the deck where the shark's going, which direction it's moving, if it has any injuries, if it has any special markings on it. And then they would tell that to person on data. Someone who's on camera is standing with GoPro and they are trying to capture the dorsal fin of the shark. That is to let us know which sharks are coming in and out of the area using Identifin. And then there was a person on bait. Unfortunately, none of the interns were able to use the bait rope. In South Africa, the only person permitted to deploy the bait rope is the skipper. And then data, where everybody on the deck would tell the person that's on data a bunch of different things about the shark. And we would also take environmentals. And then if we were to tag, we would write that data down too. And for the bait, we were only permitted to use 5 large tuna heads per survey or 5 really tiny salmon heads. And this was the data that we collected in June. So I was able to participate in over 18 hours of chumming. I went to 6 different survey sites and we saw 7 different white sharks. So we only saw white sharks at Kleinbrock.
We didn't see any at Seal Island. We actually saw one 10 minutes after the survey period ended, but we couldn't use that data. So this picture down here, this is a screenshot I took from the GoPro footage that I captured. I was the only one that was able to capture the sex of a shark. So this one was a female. And then this is one of the dorsal fin photos that I got. And these dorsal fin photos are very, very important to this research because it goes into this semi-automated software program called Identifit. This uses the notches on the dorsal fin to identify which species are coming in and out of the area. So it's kind of like our fingerprint. Their notches are very, very unique to them. And this program, it has a 98% accuracy for matches rather than manual matching, where we would draw it ourselves and try and compare it. It also reduces identification time, and it's a non-invasive tracking method. And all this data that we collected through the White Shark Project is currently going towards the orca predation research that's going on in Mussel Bay. So recently, there's been a lot of orcas coming into the area. I don't know if you've ever heard of Port and Starboard, but they're very well known to Africa to, pushing these white sharks away because of their predation. But the way that we use the white shark dynamics data is that it establishes presence and identifies the abundance, and it uses the location data and the survey data. And then these are the pictures of Port and Starboard breeding on white sharks. And it also goes towards conservation. So it introduces the non-invasive methods like Identifin. It supports public education and science communication. So as interns at Oceans, we were required to do many different things for social media. One of them was creating an infographic. All the interns had very specific reasons why they were there and very niche interests. So I did mine on white sharks. I talked about their population trend over the last 25 years, why there's a decline in the area, why they matter, and how humans can coexist with them. And then this also informs discussions and provides government agencies with evidence for conservation. And then this is some of the conservation that's currently in place in South Africa. So South Africa was the first country in the entire world to put protections for white sharks in 1991. And then in 2004, they established the National Environmental Management Biodiversity Act. And this made it illegal to kill, injure, remove, transport, or have the sale of white sharks. And then underneath that act, they had the Threatened or Protected Marine Species Regulations in 2017. This was putting a lot more permits for organizations, like research organizations like Oceans, and putting in a lot more permits for cage dive regulations. And then South Africa also has 42 marine protected areas around the Eastern and Western Cape. You can see all these protected areas around South Africa. This is only 5% of the exclusive economic zone. And the one that's closest to Mussel Bay is number 25, which is Geukensia. And I had a lot more experiences at South Africa and at Oceans rather than just working with white sharks. I was able to go diving. I got my dive certification. During this expedition, I was able to see a bunch of the benthic sharks that we were catching during the ethical fish biodiversity assessment. We were also able to tag and handle sharks. So we weren't tagging white sharks, but we were able to tag the smoothhound shark. So right over here. And I got a lot of experience just handling sharks in general, which will help me in the future with larger sharks. This wasn't even supposed to happen. The necropsy, this pygmy sperm whale washed up about 2 days before my flight, and Oceans got called and said, bring all your interns to the beach. We really need help with this necropsy. And so that's me in the middle over there trying to help the other mammal organization that's in Mussel Bay with this necropsy. And then we did have opportunities outside of Ocean to explore South Africa. I did go cage diving. That's me and 2 other interns in the cage. That's one of the photos that we captured of the white sharks. and I went to South Africa, so I had to go on a safari. And I saw a lot of the animals. I saw the big five. And then, thank you so much. Thank you, Oliver, for assisting me in this project, and Oceans for taking me in. And this was the beautiful sunrise, actually. I was so every day.
Any questions?
Okay.
So you said before that Seal Island was like primarily where the white sharks were located around Mossel Bay.
Yeah.
But then you've also stated that you didn't see as many this year. Why do you think that is? Sort of possibility.
So, this is more of Oceans, like, idea of why we're not seeing them at Seal Island anymore. White Shark Africa is that cage diving operation, and they always go to Kleinbrack. They're baiting the water, and they're the ones that are teaching these sharks to come to the boat. Boat means food. And so that's our prediction of why we're not seeing them. And that operation wouldn't go to Seal Island because it really, really reeks. Like, if you're upwind, like, you can't be on the boat without getting seasick. It's so bad. Another thing is the orcas have been pushing all the sharks away. So now they're finding a new aggregation site around Mossel Bay. And we're not seeing those large white sharks that you saw in the pictures before. We're only really seeing juvenile sharks. Yes.
That kind of brought up the point that I was thinking of, which is like, what's the general culture between the ecotourism, like between conservation and cage diving operations? Like, I know sometimes there's like sort of friendship between them versus.
So there is definitely, especially in South Africa and with Oceans and White Shark Africa, there is a very big divide between two. Although White Shark Africa does help us in some ways. It's tough there because cage diving is so well known and it brings in a lot of money to South Africa, whereas like Oceans isn't doing that for the community. Yeah, it's still up in the air there. That's why there's a lot of different permits going through. Frank?
What's the main food source of white sharks in that region?
It was Cape fur seals. We have been using a lot of tuna and salmon, so I think that they've been going off of the Cape fur seals since we haven't been seeing them in the area, but Cape fur seals were their major food source. Thank you.